we're back. Yep.
Give me a sec, I'll check that we're back.
What am I doing with this?
Check Twitch to see if we're back.
Oh.
You're live, you're back.
Woo! Yo, we're live.
Just not USB ports.
Heads up, I'll type F every time it goes down.
Ladies and gentlemen,
It's the fastest way to look.
Unless you've got a USB-C to USB-A connector. But
I believe, yeah. Okay, Dave, all yours.
Me. Alright, so I'm going to go through the solution for the little vampire question that I wrote. Does it make sense to do it on the board or straight in VS Code?
Up to you.
well, we haven't got VS Code yet, so
Alright,
board
well,
it is.
board it is. Alright. Check us some markers, would you? Purple one. And yep, give me all of them. Hooray. Alright, so
Go ahead, jumping better.
we've got three
Successfully
inputs.
streaming 1080p.
We've got, can you bring up the questions? So I believe it's some function vampiric terrain.
Angry noises.
And we can assume R0 contains the address of the player data structure, if I'm not mistaken. Someone fact check me on that.
R0 contains the address of the party data.
Yeah.
Sure, party. So it contains a pointer to like the start of all the data, and then R1 is the spellcaster and R2 is the target. Okay, and we need to check that the spellcaster is alive because dead people can't cast spells very well. And we need to check that the spellcaster has enough mana to actually cast the spell, because if he or her doesn't, then they can't cast the spell. And so in either of these two cases, nothing happens. And then if the spellcaster is alive and they have enough mana to cast the spell, then they're going to steal up to 20 points of health from the target and then add it to their own health points. So here's our function vampiric terrain. So what we're going to have to do is I'm going to have to work out which players are the ones we're going to have to like modify their traits. So I guess what I'm going to do is I'm going to use, I can always use more registers. So I want R1 to be a pointer to the spellcaster, and then R2 to be a pointer to the target. So by default, how the data structure was set up is that R0 points to the top. We have 2 bytes here for the size,
Intel CPU is really good.
and then we have big 40 byte chunks for each player. So if R1 points to the spellcaster, so if R1 is 2, then R1 will be pointing to the player with ID number 2. 0, 1, 2, which will be this one here. So I want to add 2 lots of 40 bytes plus 2 bytes. So I'm going to take R1 and multiply it by the number 40, and then add 2 afterwards. So that way it points to the start of that player. So I'm going to move into R3 the number 40, multiply R1 by 40, multiply R2 by 40, and then I'll add 2 to each of them. Add R1, 2, add R2, 2. And so that will ensure this person here is the target, then R2 points to the start of their record, and then if this person here is the caster, the spell caster, then R1 will point to them. So this is just some nice work to clean it up, to make the problem a bit easier for me to solve, now that my registers are set in the right place. And now I know whatever R1 is, it's some number somewhere pointing in memory, I can just offset by either no bytes or 2 bytes and extract out the health points or the mana of that person. So I guess the first thing I want to check if the spellcaster is alive or not. So the spellcaster is pointed at by R1, and if the spellcaster is alive, then the health points should be strictly greater than 0. And the health points were stored as 2 bytes in the very start of the player section. So here was my 40 bytes. Really helps to draw these pictures so you don't get lost. How was it cleaved up? So we have 2 bytes for the health. We have 2 bytes for the mana, not to scale TM. We have 4 bytes for the alignment. And then we have 16 bytes for the name and 16 bytes for the class. So if R1's pointing at the start, then I just need to load a half word from where R1 points and check that it's not 0. Because if I load a half word from here and it's 0, that means that player is dead. I have to be very careful here. If I load a full word, I'm going to load both the health points and the mana in one go, and that's going to get me some rubbish results. It's going to tell me this player has like 10 billion health points or whatever. That's not useful, right? I don't want to do that. So I'll call this check spellcaster alive, just so I can keep track. And so all this code here just like sets up my pointers to be pointing in the right place. So I'm going to load a half word from where R1 points, and then store the result in R3, because I'm just using R3 for my like dummy scratch register. Okay, I can then compare R3 to 0, and if they were equal, that means the spellcaster is dead. So do nothing, so then just branch to the finish. So BEQ to end, and then somewhere else, end is just like BXLR. Okay, so whenever we go to end, that means we're finished. So if the spellcaster attempted to cast the spell and the spellcaster is currently dead, well, nothing happens. Dead people can't cast spells. Make sense? So the next thing we want to check, if he's alive, does he have sufficiently many mana points, right? So now we'll go check spellcaster mana.
Is that the USB equipped?
Okay, so what we want to do is we want to load this parameter and then check if there's at least 30 mana points. So what I can do is I want to load a half word from where R1 points offset by 2 bytes. And we can use the load with offset instruction to do that. So load into R3 where R1 points offset by 2 bytes. And it's really critical that you don't mix up your loads with your half loads or your offsets with 2 or with 4. You're just going to load rubbish, right? If I accidentally offset by 4, I would be loading the first 2 bytes of the alignment, and I just get rubbish, right? So you have to be really careful with your offsets, or you load silly things. I mean, I'm sort of like only 80% confident I've got this right. I'm sure someone will call me out that I've got this in fact wrong, and I am loading the wrong place. But I'm trying to be as careful as I can be. So R3 should contain how many mana points the spellcaster has, and we got to check that he or she has at least 30 mana points. So I want to compare R3 with 30, and then branch less than to end. Because if there's less than 30 mana points, then I can't cast the spell. BLT.
That's fine.
And this would be a really good case to check. Does BLT branch if it's strictly less than, or if it's less than or equal to? And I have no earthly idea, so this would be a good time to check the cheat sheet. Can someone got a cheat sheet on it?
Fucking failed. Yeah, sorry. What was the question, Dave?
BLT. Does BLT branch less than or less than or equal to?
Less than.
Less than.
Slightly
LE,
less than.
BLE is less than.
BLE is less than or equal to. Okay,
Yeah.
so this is the one I want. So this is branch strictly less than 30. So this would be a really like silly edge case. Oh, thank you. This would be a really good edge case to get tripped up on. So this is the point where I check my cheat sheet. So here's my cheat sheet. Let's have a look. BLT signed less. BLE signed less or equal. So BLT is indeed the one I want to use. Branch if R3 is strictly less than 30. And if so, go to the end, go back home, nothing happens. All right. So far, nothing interesting has happened. This is all just like checking if I can even cast the spell. And so now we'll like actually cast the spell. So I'll toss this out. So this sort of continues. So like this continues up here. And this will be, I guess, like cast vampiric train. And so far, I haven't actually used any of these labels to branch to apart from end. The labels are just sort of helping me keep track of what's going on. Make the code a bit more readable. They're not mandatory, but they help me, right? This part's clearly checking if he's alive. This part's clearly checking if he's got enough mana, and then this part will actually like do the thing. So to cast a spell, that costs 30 mana points. So I better decrease the spellcaster's mana points by 30. So R3 still contains the number of mana points, right? So I'm going to subtract from R3 30. And then I want to store R3 back into R1 offset by 2. I want to store it from the same place I got it from.
Give me a
So
second.
store R3 R1. Oh, without even realizing, I've made an error here. So, can anyone in the audience spot what error I've made?
What have you done?
Yeah, strh, right? This would store a full word and would like garble up the first 2 bytes of the alignment. So strh, because I'm storing a half word back. Very, very careful, because I exactly just made the mistake that I told you not to make, right? So load the half word, store the half word. All right, so all I've done so far is dinged my mana points down by 30. Then what I want to do is I want to find the target's health points and check if he's got at least 20. And he's got at least 20, then take 20. And he's got less than 20, then just take whatever's there. And if he's dead, then I guess I'll take 0 HP because dead people have no health points to steal. So I'll still cast the spell, and nothing happens to me. I've just wasted 30 mana for nothing because there's no health points to nick. All right? So really I should call this like maybe mana decrement would be better. Mana, or like pay mana. That's a good label. So I'm going to pay the cost to cast the spell. So I paid my mana cost, and now I'm going to cast the spell. So I will check target HP. Okay, so I need to get the target's HP. Where does that live? Well, R2 points to the start of the record for the target because we set all that up at the very start, so you don't have to worry about it. So I want to load a half word from where R2 points and then put that in some register. I guess I'll put it in R3, that's my designated scratch register. So we'll load a half word into R3 where R2 points. This time I'm not offsetting because the first thing in the record is the health points and the second thing in the record is the mana. So this will go to R2, which points at the start of the target, and load the first thing there, which will be his or her health points. I then got to check if there's at least 20 points there. So compare R3 with 20. Okay? And if it's at least 20, I'll steal 20. And if there's not at least 20, I'll steal all of it. So I guess I want to branch, and now I've got to check my cheat sheet again. I want to branch, if it's greater than or equal to 20, steal 20. So signed greater or equal to is BGE. So branch greater than or equal to, steal 20. And then otherwise I'll steal all of it. Okay? So if I want to steal all of it, that means he's got 19 or less HP. So now his HP is 0. So I want to add that HP to the spellcaster's HP, which means I guess I had better load the spellcaster's HP out, add R3 to it, and store it back. So load a half word into another register where R1 points. So load from where R1 points, offset by nothing. So that means R4 will contain the target HP. So I should put a comment there remaining. So R4 is the spellcaster's HP, I beg your pardon. I really hope this is being recorded. Are we still going?
Yeah, it's still going.
Okay, cool. Okay, R4 is the spellcaster HP. Add the stolen health points to it. Add R4 to R3. Okay, and then put it back. So strh R4 R1, and then 0 out the H points and store that back for the target. So mov R3, put a 0 in R3, and then strh R3 where R2 points. There we go. So this is the critical step here where I'm taking the target's health points, adding it to mine, storing it back in R4, and then I put R4 back into where R1 points. Because at the end of the day, this function returns nothing. It's just modifying things in memory. So that's if I want to steal all of it. Now I've got to do it again if I want to steal only 20. In retrospect, I probably could reuse some of these loads and stores, but too late now. we can go back and like optimize it later. Pre-motor optimization is never a good idea. It's really easy to get lost. Am I going to have much room if I go down? Oh yeah, about to here.
Yep.
Okay. And then I guess once I'm done stealing your health points, I branch to end. So B end. Otherwise, steal 20. So I load the target's HP, and I nick 20 from it, and I load my HP, and I add 20 to it. So LDRH into R4 with R1 points, which is the spellcaster HP, and then add 20. Add R4 20, STRH R4 R1. So all this section does is basically plus 20 caster HP. And then I want a minus 20 from the target's HP. Well, target's HP is already in R3, right? So I don't need to load it again. So I can then just go sub R3 20 and store it back. STRH R3 where are 2 points minus 20 target HP. And then B end. There we go. That's like a moderately verbose, relatively readable solution. Certainly, there's lots of wasted code here. I mean, this is redundant. These stores are redundant. But this is a perfectly valid solution. Again, we're not looking for an optimum solution to the exam. Any would do, and this would work just fine. By dealing with the this at the start, by like making sure my pointers point at the right place, it means I don't have to juggle them later on. So by doing this like bookkeeping work at the start, it ensures that R1 points at the start of the caster's record and R2 points at the start of the target's record. So I put little comments here to represent it. So R2 is the caster and R1 is the target. Because if the target is like player ID 5, I don't actually care about that. What I really care about is what's the address of the target in memory, and that's what R1 and R2 are now point at. So that way I can like load and store HP and mana relatively easily. So we do the little bookkeeping work at the start, so that way you don't got to worry about it later. Ta-da! That would be my solution. I know it is because I wrote it. Any questions, either from the chat or from the audience?
No, only questions from the chat are about using Spider during. Oh, hang on, we have one. Yeah, we have another question about how important are label names.
Again, these label names, I could not put any of these here. You know, let's strike them all out because I'm a jerk. We need steal all, we need steal 20, but I can get rid of this, I can get rid of this.
Yeah, so
I could make them just comments instead. Maybe for some reason I want to branch to it later, I don't know.
there's no real like hard and fast rules about it. Just like whatever makes it easy for us to, you know, at a glance work out what you're doing. So label names that make sense, comments, etc.
Yeah, I could have just as easily written check spell caster mana.
Yeah, like just, you know, there's no like rules or anything. We're not going to take marks off because your label names aren't perfect. It's more just about making it easier for us to, you know, see what you're doing if your solution doesn't work.
I mean, be sensible, right? What does the code underneath the check spellcaster mana label do? What probably checks the mana of the spellcaster. Checks it against what? I mean, I don't know. I'd have to put more comments in there. But like, this is a nice balance between like verbosity and actually saying what's going on, right? I could make my label check if the spellcaster's mana is at least 30, and then if not, do nothing. But that would be a pretty lousy label name, right? So, you know, pick something that contextually makes sense.
We've got two more questions.
Yeah,
we have someone wants more clarification on how you work around the 16-bit null pad at the string.
Oh, sure. So thankfully for this problem, we don't have to look at it at all, but suppose we did. If you want to do something with a name that is maybe, I don't know, well, we'll see this in the next question, but if I want to check if someone is a vampire, when we read the string out, we keep reading out characters until I see a null character, and then I stop reading. So for example, in this fantasy land, my name would be encoded as DAVID, null character, null character. I'm just going to write capital N for null because I'm lazy, but these are like really null characters. Not, no, that's dumb. I just write this. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There we go. So in the data structure, this is what my name would look like. DAVID, no, like a bunch of nulls, so the entire length is 16 bytes.
That looks like it says 10101010.
It does, because these are supposed to be like backslashes, but it's not. It's hard to draw.
Yep. So, in ASCII, \0 is a special, character. It's interpreted as one character. So in like an A or a B or a C, they're one character. \0 is interpreted as one character, and it just means a byte full of zeros. It's the null special character.
Yeah. So if I had my ASCII table, what's David in ASCII? 50, 54, 51?
Numbers, spaghetti.
Something. So DAVID is like some random hex numbers. You have to go look at your hex table. I don't know off the top of my head. Let's just suppose, for example, it's like 54, 51, 63, 59, 54, and the rest would be 00, 00, 00, such that the length of the entire thing is exactly 16 bytes. So if your name is not exactly 15 characters long, then you just chuck a bunch of null bytes until it is.
But even if it is 15 characters long, you need one null byte.
You always need at least one null byte on the end, and the reason is otherwise you don't know where your name stops and your class begins.
Yeah, so if you remember in the last question we did, how we went through our numbers until we loaded a 0. Well, it's the same thing for a string, right? You keep going through all the letters of the string until you reach a 0, and that's how you know you've reached the end of your string.
Yep.
So that's why we do what we call null termination.
So if I forgot to null terminate my name, and my class was a paladin, and I'd accidentally read my entire name out as David Paladin, which is probably not useful, right? I hope that answers this question. If not, I'm sure that person will be back for more. What was you said? There's another question as well?
Some clarification as to what the multiplication by 40 does and why multiply instead of add. And
Oh, sure. Okay. So R1 and R2 refer to the players in order in the list. So if we have a look at the player structure I gave you, I'm sort of running out of room here. I'm going to move over here. So in the data I gave you, there was 2 bytes at the start for the number of players in your party. And then there was 40 bytes here for everything you wanted to know about Astrid, the good priestess. And then, who was the next character? I think Ulrich or something? I don't know. And then 40 bytes for, I don't know, James. Yeah, pretty unoriginal with the names here, that's alright.
James, the totally normal dude.
Yeah, James the normie.
It's Astrid, Ulrich, Zendril, and Azar.
Yeah, so we've got some real edgy names going on here.
Yeah, and bloody James.
Alright, so why multiply by 40?
Nate Jeff.
So if R1 contained 1 and R2 contained 2, that would mean that the spellcaster is Ulrich and poor mate James here, he's the target. But these are just numbers, 1 and 2. They don't refer to where Ulrich and James actually live in memory, right? So to actually work out, to make R1 and R2 point to these records in memory, what I need to do is I take R0, and we know R0 points to the start of this data structure. Well, I'll take R1 and multiply it by 40 to get 40. And then I'll take R2 and multiply it by 40 to get 80. I add 2 to both of these to account for the size. So then I get 40 plus 2 is 42. 80 plus 2 is 82. And then what I do is I jump from R0 42 bytes down to get to Ulrich. So this is going to be my new R1. And this is going to be my new R2. And I probably forgot to do that, didn't I? Oh, I actually forgot to do that. I forgot to add R0. So R1 here will just be 42 instead of like OX bajillion plus 42. I actually didn't do that, so I'm glad you brought that up. So I guess I also got to sneak in here, add R1, R0, and add R2, R0, and then afterwards add 2 to both of them. And so the reason we do that is because for every player takes up 40 bytes. So if I want the 7th player, I have to count 7 lots of 40 bytes forward.
Pretty good.
So a half word is 2 bytes, a full word is 4 bytes, a player is 40 bytes. So you have to jump, that's why we multiply by 40, to jump 40 bytes.
That's not hardware acceleration.
To jump in increments of 40 bytes forward. And I didn't add R0, so I have to do that. Anyone else?
No, we all good?
All right, cool.
So at some point I will sit through the stream and like bog all this into a assembly file, and yeah, hopefully at some point tonight all these code things will appear somewhere on Waddle or on Git.
Me and
or
John will
whatever.
punch us through. Well, I'll just go to the stream and read this off and tippy type it. But there it is.
Spider and this other shit. Yeah.
Okay. Cool. All right. What's next? We have some Python questions.
No, there's more vampire stuff.
Oh, there's more vampire stuff.
Yeah.
What's
Oh, it should be. Did it
No.
get? Oh, did Ramesh pin it?
Chippity Chop?
Oh.
Question 4. Murdoch, would you like
Spent
to
so long on that question.
take the wheel? All right.
bad.
Shout out
Question from the
to
audience? No. Okay.
shout out to Murdoch, who's joining us on today's live stream to help with some of the Python content.
Oh, where's that marker, David? The red one. The red one again.
Do you want a marker? I've got Spider up and working. So do you want
You
whiteboard
put-
or?
No, I'll use the whiteboard
Oh,
for now.
whiteboard for now.
I'll erase this.
Yep.
So
Yeah.
you've got it on stream forever. Forever and ever. Oh, God.
I'll shove over a bit, yeah.
Are you sure Twitch is set to record what?
I believe it is. If it's not, we could get a spicy surprise.
Because I'm not recording.
Yeah.
Yeah, I've got this set to Dvorak for
I don't need a
it.
password to protect my computer, I just put it in Dvorak. No one can use it anyway. Okay, now that you're all masters of assembly,
Praise the
we'll
Lord.
move on. Okay, so what does the question say?
Question is, so first question is, what are the key features of the Monte Carlo simulation? Given an unbiased coin, how would you go about determining the probability of a result being heads using this approach?
Okay, so effectively Monte Carlo is just about repeating something again and again to find out a quantity. So in reality, if you want to know how often, for example, a particular coin or a particular die lands on a particular face, you don't know that it's an unbiased coin or unbiased die. The only way to find out really is just to test it. So you flip it again and again and basically find out the proportion. So we'll do a little experiment. Can someone get ready to tally the heads and the tails?
I can tell if you like.
Okay, sure. Alrighty. So I'm going to repeatedly flip this coin. Okay.
Tails.
No. Okay.
Table.
I got heads.
I got tails.
Heads.
Drop my coin. Tails.
Heads.
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 No, shut up, Dave.
Tails. Tails. Heads. Heads. Tails. Heads. Heads.
Riveting stuff.
Tails. We've got a little bit more. Hang on. Tails. And heads. So do you think that's a fair die?
Fair coin.
Fair coin, yeah.
So we've got 9
Two-sided
heads
die.
and 5 tails.
Yeah.
Well,
Yeah.
Is that statistically significant?
It probably is because I was flipping the coin in a particular way to get more heads.
Murdoch was cheating us,
Yeah.
right, okay.
I just thought that might be fun. It didn't turn out quite as well as I wanted
Yeah.
Yeah, so basically Monte Carlo simulation is just about repeating the same thing over and over usually and somehow computing a numerical quantity from that. That's as opposed to, theoretically predicting from models what the probability should be. So, you would just say, oh, it's got 2 sides, 2 sides are roughly the same. By symmetry, it's probably 1/2 chance to land on heads, 1/2 tails. But in reality, Monte Carlo is about actually testing it and finding out. Yeah, could you please bring up the question again?
Oh, yep, sorry. I'm too busy spamming emotes. Cool.
Yep, well, I guess we've just done this. Given an unbiased coin, how would you go about determining the probability of it being heads using this approach? Basically just doing this, tallying up the heads and the tails, taking the number of heads, 9, divided by the total number of flips, so 9 on 14, and that will give you the probability of it being heads. The more trials you do, the more accurate it's going to be, the more it will approach an even number of heads and tails. And so that's one aspect of Monte Carlo simulation as well, is that the more trials you do, the longer you let it run, the more accurate it will become. But it is still influenced by randomness and noise, so the answer will never be perfectly precise. You do have to let it run a lot. So it can be quite computationally expensive. Come on, John, next question.
You are given it.
Okay, yeah. You're given the distance travelled by a vehicle at different points in time while going from Sydney to Melbourne. Okay, so the data has been collected in such a way that it is noisy, not accurate. Okay, let's just start by assuming. Where's this eraser?
As well as the difference. I don't have Loading Ready Run anymore, they all expired. That challenge
Okay,
was
so
like
we've
4
got
years
distance
ago.
over time. Right. So we're going from Sydney to Melbourne. I suppose I'll put, I don't know. Is that right? Sydney to Melbourne? Is that what it says?
Yeah, Sydney to Melbourne.
Okay.
That's a long drive.
Right. Sydney, let's say that's at t equals 0, you know. Melbourne, whatever, doesn't.
T equals like 10 hours-ish.
Okay, we'll say t equals 10 then. Sure, measure it in hours. Okay, let's just say the car, you know, probably went roughly the same speed the whole way.
Yeah.
Obviously not true. But
Well, I mean, most of it's on the Hume Highway, so yeah.
Yeah.
Now the thing is, let's say that's the underlying actuality of.
Yeah, it's a bit hard to see.
What does it show?
The dotted line.
Oh,
Really
well,
bit darker.
I'm about to draw over it again. But
Yeah, take the purple. Purple looks
I have
like-
extra colours.
okay.
My purple marker.
Sneaking it.
Okay. Sure.
Yep, that's
Okay.
visible.
So let's say in actuality that's what the car really did. We don't have access to that true information because it says that the data has been collected in such a way that it is noisy and not accurate. And it says we've given points at different points in time, or given the distance at different points in time. So we've got several points that have been sampled and they're not accurate, they have noise, okay? So it's probably like maybe one there, maybe one there, there, let's do that, there, okay? Right, we have something like that. These red dots will be the actual data that we're given. Okay, now it asks, you're asked to estimate the distance travelled at some intermediate point in time. Okay, so somewhere between the first real data point given and somewhere between the last. Will you use interpolation or regression for this purpose? So we can argue over the technicalities of the wording, you know, what the difference is between interpolation and regression. Interpolation really is just if you have a series of values, can you predict? We have a series of distance values, d, for different points in time. If I now give you a time that's somewhere in this range of this first data point and the last one, so if I ask you here, what is the distance travelled? Okay, all we have is these real data points. We don't know this real underlying phenomenon with the dotted lines. That would be an active interpolation to try and guess what this distance would be at this intermediate value somewhere in the range of real t values that were given. That would be an active interpolation. But
can I throw a quick example?
yeah, sure.
Yeah. So like, you know, if you have like a data point here and a data point here, and you know, you're told, okay, what's, you know, the underlying curve right in the middle? Well, interpolation is saying, all right, I'm going to draw a line between these two, and you know, I want to know it here. Okay, sure. That's like my interpolated point there, right? We're just sort of making the most naive possible, you know, guess that it's somewhere in the middle. So yeah, that's like a linear interpolation.
So interpolation, for the purpose of this course, really is about connecting the dots. So it's taking the real data points and assuming that the distance that the car travelled over time is somehow, you know, you connect the dots, right? So
Yep.
you could do it via a linear interpolation, which if you've done it in NumPy, that would be like numpy.interpolate.interp 1d, and the order of that is 1. That would draw straight lines between the dots. That's a linear interpolation. So that would be like this. Okay. Now that really doesn't make any sense here, because how can the car have travelled this distance and then travelled less distance further in time? That doesn't make any sense.
Yeah.
So in this situation, you can see physically it doesn't make any sense to try and interpolate.
Yeah, because if you interpolate at that point, you've gone, you know, a fair way, and then if you interpolate like half an hour forwards, you've actually gone a smaller distance. So interpolating in this case really doesn't make any sense whatsoever. Like, it's going to have crazy effects just because the data is noisy.
Yeah, fundamentally, and you could do higher order interpolations like the third order or cubic interpolation, where you actually fit cubic equations between each data point, and it looks nice. It looks nice and smooth.
Yeah.
But really, you're still connecting the data points. We're told that the data is noisy, okay, and we can tell it's noisy because the distance is going up and down. That just doesn't make any sense. So you wouldn't really want to connect the dots here because you know the real data itself isn't even correct. It's got noise in it. So what you want to do here is more fitting a function to it, or finding a line of best fit, which would be, reconstructing that sort of line roughly. And that is an act of regression, where you have a particular function. It could be x squared, scaled and moved around. You might want to fit that. Here, this is just a linear interpolation, so we're just trying to fit an equation of the form y equals mx plus c. Or, d, the distance, equals some constant times time plus some constant.
Yeah.
That's what we're trying to fit here for a linear interpolation. Linear regression.
Yeah. So even though our regression model may not be perfectly accurate, it's going to be a better, it's going to have a better result than trying to interpolate. We just realised the interpolation is never going to work. So it's better to just live with the small error in our regression and call it a day, I think.
Yeah, even if you did fit a function where you got zero sum of squared error, like interpolating, the sum of squared error is zero, but obviously it's wrong.
Yeah.
It doesn't make sense. So this is a bit of common sense as well, determining whether you should use interpolation or regression. So apply a bit of common sense to the question that you're given, and whether you really want to connect the dots exactly, or whether you want to try and model an underlying function, which we don't know, like a line.
So we've sort of used the context of the problem here to, choose, in that we know that it should look roughly like this blue line here. Driving is something you do at constant speed. You're not going to turn around and go backwards or whatever. So kind of just have a bit of a common sense, think about it for 30 seconds. You'll probably get the right
a question from chat on the difference between np.polyfit and np.poly1d.
I'm trying to remember the exact.
Let's read the documentation.
Let's actually read the documentation.
Yeah, okay. I think it's a good idea.
Poly1d will make a one-dimensional NumPy polynomial object. Polyfit will calculate a Poly1d from a set of data.
I believe reading the documentation is itself a very important skill. So let's do that.
Yeah, I think it would be a good idea actually. Because you might get what we're saying, it's good to know how to look it up.
So Poly1d
can we
is the
switch
type.
to broadcasting this?
And
Yep, that's what I'm doing right now.
Is for fitting a Poly1d to a data set.
Okay.
And so first off, how did you actually look at the documentation?
Yes. See this useful help function that Python has.
What is
Yes,
it?
indeed.
NumPy.polyfit.
That text is a little bit small, that's all. So.
Yes.
And so importantly, you call, if you don't know what a function is, you call help on the function and it prints the lovely little information that tells you what it does, what it takes, and what it spits back out.
You'll have to import the function first. So import NumPy or whatever. Pretty sure you'll have to do that before it will find the help.
You do.
Yeah. Okay.
np.poly1d. Let's have a look at this one. Oh, sorry.
You have to use the fully
of course.
qualified now.
Okay, NumPy.poly1d, and this is a class. So it looks like np.polyfit will return you an object of type np.poly1d.
Yes.
So poly1d is the actual object that exists, and polyfit is the function that gives you one.
Yeah.
Does that make sense?
Can I have a look?
The documentation's right here.
Yeah. So let's see if we can make this. Can we make this larger? The text, is that possible?
I can try. I can also put this into Warwick for you.
I guess you could just open a terminal, crank the font up, and just do it in there, right?
You could.
Computer hasn't crashed yet.
I think this will look fine on the stream. Are you fine dealing with it like this? Because it'll look fine if you full screen the stream.
Yeah. What if I how do I open a terminal? What if I do that? Oops. Terminal. If I open.
That will not stream.
Yeah.
Oh, okay. Yep. Okay.
I'm only streaming the one window.
I see. Okay.
So if the text is a bit small, just full screen stream, chuck it on 1080p, and you should be able to read it. Sorry.
Don't know if it's possible to increase the size of this. So
It's readable even in the window.
maybe we'll just extend that out a little bit. And can we control? Nope. Okay.
No, there's no zoom button.
All right. Okay. Let's go ahead and clear everything in here. We're going to go help NumPy dot polyfit. Okay. These documentation pages can be quite long. You really just want to start reading from the top usually. The top has the most important information, and as you can see here at the end they have some examples, which is really nice when they have that. But not all documentation is created equal.
I think it actually talks about poly 1D at the end as well. So yeah.
Yeah. Okay, so you want to kind of start reading from the top here. So here we go. Least squares polynomial fit. Okay, so it tries to fit a polynomial equation to a bunch of data points then. Fit a polynomial p of x equals p naught times x to the degree of the polynomial. Okay, well, what's deg? Okay, that's one of the arguments. So let's say we're trying to fit a cubic equation. So we're running polyfit, we've got our x data, y data, and then we've put in 3 for the degree. Okay, so like, can we enlarge this one? Yes, we can. Oh, nice. Okay, so let's say we've got put numpy as np, then we've got, let's go a equals np.polyfit. And we're going to have some x and y data in a second, I suppose, but let's say we have that. So we're trying to do third order polynomial fit, which is a cubic equation fit. So it fits a polynomial. Right, and it says p of x equals p naught times x to the 3 plus p1 times x to the 2 plus p2 times x to the 0. But what is p? So I think we'll find that's what it returns. So here you can see it has a list of parameters. These are all the inputs you can give it. Often there are a lot of optional inputs which really you don't have to worry about unless you really need them. We can see up here you've got polyfit, x, y, deg. They are all required. You need to input them. Then these other ones, they start having the form, parameter name equals something. So that's an optional keyword, which means you don't have to input it yourself. If you don't input anything, then this archond input will just be set to none. So when you're first trying out a function, probably just leave it at all the defaults, just put in the arguments you have to, which here is just x, y, deg. Okay. Parameters, it tells us in detail exactly how you should format all those inputs. So if you're not sure if you should put in a number or an array or whatever, you'll get that here. For example, it says x array-like, shape m, comma. Okay, so that means a numpy array, numpy.array, and then just like a list of values. Okay, that's a numpy array of shape m, comma, and that's the length m. So we know that's the sort of input it's expecting for x and for y as well. Returns p. Okay, so it returns p, and it returns in p the polynomial coefficients, highest power first. Okay then, so if we run this polyfit function, looks like we're going to get a list or a numpy array back. The first one, actually let's write it like this. It's going to try and model this equation. It's going to try and do y equals a times x to the power of 3. That's how you write to the power of in Python. In other programming languages sometimes you have that, but that's not the case here, okay? Plus b times x to the power of 2 plus c times x to the power of 1, so just x plus d. Oops. Plus, did I change? No. Plus d. Okay. Okay. Yeah. So it's going to return an output that is the polynomial coefficients, highest power first. So it's going to return us an array with a in it, then b, then c, then d. Now you can see from this how you would then reconstruct this cubic equation. So let's maybe make up some data. So x equals np.linspace 0 to 10. Oops. 0 to 10. Number of samples in here, let's go 100. Okay. Y equals, maybe we won't do 10, that's too much. Can't write. Oh, sorry, 100. Just do 10. Y equals numpy.array. And here I'll enter some random data that's sort of semi-increasing. Let's do it like that. 0, 2, 1, 5, 3, 6, 1, 2, 3, 4, 5, 6. 7, 8, 9, 10. Okay. Got some pretend x and y data.
Well, comment like
Oh, sorry?
Can I comment line 15?
Ah, yeah. This is not real code. This is just me explaining. That's kind of what.
Double dash.
Oh, double dash.
No,
you said?
that's fine.
Oh, double slash.
Sorry, it's slash.
Okay. All right. Okay. Let's.
Think
Yep.
double dash. That's good.
Okay. So let's run this.
Simply won't use double dash.
Yep. Run. Okay. Now let's see. X is that there. Again, sorry, I can't increase the font size in here. That's just what we're gonna have to deal with. That's X. That's Y. And then what's A? We do expect an array of those coefficients. That's consistent, so that could be this is A times X cubed, B times X squared, plus C times X plus D. Okay. Now the other function you asked about, numpy.poly1d, let's have a look at that. Okay, again, documentation, pretty long. Usually the most important stuff's right at the top. That's what I'd recommend, just starting from the top. Or if you see examples, you might want to have a look at those too. Okay. Let's see. So brief description there. Okay. Not very helpful reading from here. Still don't really know how to use it. I know that there's one required argument and I don't need to input any more. Okay. Okay, here it's going to tell me what the first argument is. So array-like. Okay, so I should call this function np.poly1d. It is expecting one required argument that is array-like. So I could give it a list or I could give it a numpy array. Okay. And there we could have like there would be like a numpy array with a bunch of values in it. Okay. All right. And it wants the polynomial's coefficients in decreasing powers.
It's almost as if our polyfit function gives us a list of polynomial coefficients in decreasing powers.
Yeah, that's very convenient because that is exactly the format that A is in.
Yeah,
so,
wonderful.
Of course, it was designed this way.
Yeah. This is no coincidence.
Yeah. So we've got these real data X and real data Y, but what we want to do is construct a more fine-grained view of the Y values for lots of different X values, not just for 10 of them, because we already have the real data points. So let's make a bunch of X data. Let's go X new np.linspace 0 to 10 num equals 1000. Okay. What does poly1d return? Because I don't know. Let's have a look.
It's an initiator. It's a initializer of a function of a class. It'll return a member of the class.
I see. A one-dimensional polynomial class. All right. So I'm reading that and I'm like, okay, it's returning a class. What good is that to me? How do I use that? How do I plot? Right. So I'm going to look down at the examples because unless I go now looking up the documentation for this class and stuff. I guess this is the documentation for the class, but let's look at an example. P equals np.poly1d. They've inputted some coefficients. They're printing they're printing the object. Okay, that doesn't help us very much. Oh, evaluate the polynomial at a particular x value. You can take the polynomial object, this np.poly1d, and you can use it like a function.
That's handy.
Okay, so let's go our polyfunc.
I think you just refer to the yeah.
Sorry?
It's the polynomial object bracket.
Okay.
Value bracket. Yeah.
Let's go up here and call A something more descriptive. So coefficients, right? Coefficients equals that. It's good to have descriptive variable names, especially if other people are looking at code. Then you can understand easily what's going on. So that's our polynomial function. To get our new y values, let's just apply the function to all the x values. So y new equals polyfunc x new. And it'll apply that func to each individual thing inside that long array of x values. Okay. Alrighty, let's run that. Okay. Alrighty, so we have x, original data, y. We have coefficients. Let's have a look at those. Okay, look sensible. Let's have a look at our polyfunc objects. Okay, so I guess it's a polynomial with those coefficients. Okay, seems reasonable. New x values, 1,000 of them from 0 to 10, just as I asked, and y values, it's applied the polynomial. So should I go ahead and plot this, or should we move on now to the next question? Do you reckon?
Oh no, just give it a quick plot.
Okay, I won't explain how I'm plotting it because that might come up later anyway, but I'll just import plot lib.py plot as plt, and we'll go scatter x, y, o, c equals r, plt dot plot, x new, y new, plt dot show. Oh no, okay. Py plot, there we go. Okay, I think I messed up here when I'm trying to specify some things. I guess I don't need that, I'll just go C equals red. So I'm going to make a red scatter plot here.
There you go. Oh, beautiful.
Yep.
Woo!
Okay. And yeah, this is of course an active regression, as you can see.
Yeah.
So if asked to solve a question via regression, or if you think you should, then if you want to fit a polynomial to it, like x, y equals mx plus c, or x squared.
Oh, you should also just
Yep.
plot the x's and y's as well for the interpolation view.
What do you mean?
If you also just put plot x, y, it'll do a linear interpolation between points.
Oh, okay. Okay. Yeah, I guess I'll show you a linear interpolation then. Plt dot plot. We'll go x, y, and we'll give it an interesting color. I think orange works. We'll go
It's green.
G. Yeah, sure.
Yeah. There you go. So the green line would be a linear interpolation.
Yeah. Yep. Yeah, that's a good example. Red data points, real data points that we had originally. We're interpolating in both cases, really, but for the purpose of this course, consider interpolation as being connecting the dots, okay?
Yeah.
So this green one is interpolation. This blue one is technically interpolation, but it's regression. We're using regression to find the underlying function behind the data points. That's the idea.
Yeah.
So that was a very long answer to that question,
Yeah.
but I hope that was useful.
That was nice and thorough. Pretty good.
Okay.
Oh yeah. We've sort of done this
We've
question
actually
almost.
just done that, yeah.
Yeah, okay, wonderful. So we haven't done forward difference, because I know a lot of people have been having trouble with what is forward difference, what is backwards difference. So maybe we can just do forward and backwards difference on this data set
Okay.
that we've got here.
Right.
So we've kind of done 4A and 4B, and we've started 4C. So we have a cubic fit for the data. So a cubic fit is a third order polynomial. Quadratic data, that'd just be a second order polynomial. And if we look at, I think, line 16 here, that third number is the order of the polynomial we're fitting. I'm sure you could all work out how to do a quadratic and a cubic.
Yeah. If you want to do a quadratic fit, just go to order 2 polynomial is a quadratic equation, or if you want to do an order 5 quintic equation or whatever.
Yeah,
Go
so
ahead and do it.
we've also sort of done some original data plotting. So we've plotted our original data as like a red circles with a scatter plot.
Yeah.
That C equals R or C equals G. That's how we can specify color. Probably if you look in the documentation for plot, it'll have all the different colors.
Yeah. So a scatter
Speaking of
plot.
color, let me fix something quickly. Yeah.
A scatter plot just draws the individual points. It doesn't attempt to connect them into a continuous line, which is what happens if you use plt.plot. What you doing there?
Just don't worry about me. Just carry on.
Okay. Well, I need to use a computer, so.
Cool. Our colors in the stream were wrong. Sorry.
Color? Oh, what?
Yep. Okay.
What?
Yeah, reds and blues were around the wrong way. Sorry,
Oh.
we've just fixed it. Hey, Lamau.
I don't even know how you would do that, but okay.
Yeah.
Alright.
Cool. Fun times.
Okay.
So use the forward difference approximation approach to calculate velocity and acceleration of the particle. So we've got time data and distance data. That works for this data set, I think.
Yeah. The only thing I might show first, because I've had few students ask this. So we'll go back to the board,
Yep.
I guess.
I'll put you on
More
whiteboard.
visible on this side, probably.
Yeah.
Transition will do.
Yeah. There we
Okay,
go.
so what's the actual data? We've got, let's just do the difference in, not time, that's kind of,
Distance.
oh no, difference in time, yeah. Small numbers, we'll do that. Okay, so we've got time, and we've got values 0, 1, 2, 3,
5, 8,
Yep.
13, 17,
Yep.
20,
Yep.
24.
That'll do, we'll just go up to 20 for now.
Right.
Okay. So, forward difference. Okay, so the forward difference is, I guess it doesn't really matter if that's time or any other variable. The forward difference is how much larger is the value ahead of me. So here, the value is 0. How much larger is that one? Well, that's 1
One,
greater. Okay.
Yeah.
Here, value ahead of me, 2 is 1 greater than 1. So, okay, just 1. 3, 1 greater than 2, just 1. Likewise, 2, 3, 5, 4, and 3. And here, well, there is no data point ahead, so it doesn't make sense to talk about what's the forward difference at this point. It doesn't make sense, so there is no well-defined forward distance, so we leave that out. And we'd say that the forward distance for this set of values
The forward difference.
is this here.
Yeah.
And
Yep.
so I've drawn them in the columns like this because the forward difference at this point is equal to 1, and the forward difference at this point is equal to 3. Okay? Backward difference. Back diff. Okay. Again, at the beginning, it doesn't really make sense to talk about the backward difference. The backward difference is how much larger is this value compared to the last one. Well, here, it doesn't make sense. There is no previous value to talk about, so we leave that out. There is no backward difference at that point. Doesn't make sense to ask that. Here, 1 is 1 greater than 0. Okay, so the backward difference is 1. Here, 2 is 1 greater than 1. Likewise, we'll just keep going. Okay. And as you should notice, the forward and backward difference are naturally, if you think about it for a bit, are actually exactly equal. It's just the shifted over. You see those connecting all the equal values. So the forward and backward differences are the same. It's just a matter of where you say those differences are. So if I say, what is the forward difference at this point? It's 5. What is the backward difference at this point? It's 3.
Yeah.
But the actual sequence of values for the forward and backward differences are the same. It's just a matter of, I guess it's just a matter of talking about where those differences are.
Yeah. One's they're shifted sort of one data point along from each other, if that makes sense. Like, think of it as kind of like, to think in like assembly terms, you're sort of like shifting the data points along one slot.
Yeah, and so if you're asked to plot this this velocity, is that still visible on the screen like that?
Yes, that's
Okay.
visible. Just you're kind of blocking it
Yep.
with yourself. Yeah. There you go. All good.
So say we have some function like there, whatever. Okay. Actually, let's just say it's like a continuous sort of like that. We've got a lot of points in there. Okay, a lot of discrete points. Say we've got 1,000 of them along there. The forward and backward difference. The only difference, if you were to plot them here, is that the forward difference, might be something like, what would it be? Need help calculating the forward difference? That would be like 0 there, almost, and then it kind of starts going back up again. Okay, so
Close
forward.
enough. And like
Yeah.
but chop it off a bit at the end.
Yeah. Exactly. Okay. Yeah. So let's say I've drawn a continuous line, but really like 10 different points, right? Say about 10.
Like that will finish before the data, right?
That's right. Yeah. So if this is our final data point there,
That's there we go.
let's do it. Yeah. Let's draw some actual.
And the backwards difference is going to be extra spicy.
Yep.
Cool.
I've drawn continuous lines. Sorry, it should just be discrete, but I just kind of did that so I could draw it, right?
Yeah.
So it'd be like that. That. Okay. That's the forward difference. Backward difference, well, it's exactly the same. It's just we say the backward difference here is whatever the forward difference was previously. Turns out to be the same, so it'd be exactly the same plot. It'd be going down like that and going up like that. That's not quite right. Going down like that.
So it's all the same points. They're all just kind of shifted over a bit.
Yeah, it's all just translated right. But
if you've heard the word before, it's out of phase.
Oops, I did
For
not.
all the engineers in the room who have done 2218, I think. Yeah.
Kind of messed up the dot there, but
Or I
currently taking 2218.
free 2218 revision for you.
yeah, whatever. I've messed up the plots a bit. But the idea is that if you're asked to plot the forward difference and you're asked to plot the backward difference, don't be alarmed if they're the same. They are the same. It's just one is shifted forward. The forward difference is missing a data point at the end. If you're asked to plot it, it is expected there'll be one data point missing because there is no forward difference at this point.
Yeah.
Likewise, if you're asked to plot the backward difference, there is no initial backward difference. So your plot should start one sample later. And velocity, you just forward difference of time divided by forward difference of distance, or the other way around. Forward difference of distance divided by forward difference of time. And then backward difference of distance divided by backward difference of time. It's going to give you the same velocity graph, just one's shifted slightly. That's all.
So there's some specifics of how you might want to slice up your x values to get that to all work properly. We'll put all that in the solutions file, which we'll push out once the stream is done. So probably like an hour or two after the stream is finished, we should have like full solution files for all this somewhere on Wattle. We'll let you know. I think we've basically covered off this question.
Give the graph appropriate labels.
Labels, title, legend. You want to do that?
Yeah, sure. Okay. Can we switch it over to the...
Yep, you're back.
Okie doke.
Yep, all good.
Okay. Well, let's just take this graph that we have here and let's give this labels, okay?
Yeah, labels, legends, etc.
Run it again. Let's clear it so we can see clearly what we have. Run it again. There we go. So that's the graph we have. Okay. So I can't always remember the commands for doing this, and likewise you may not remember. What I'd recommend is using this psearch function inside IPython, okay? This allows you to search for functions which you know exist, you just can't quite remember the names of them. I find this quite useful, so you can search for an exact name like numpy.whatever. Let's search for matplotlib.pyplot dot. And I don't know exactly what it's called, but I know there's some method that has the word label in it that's going to allow me to label the x and y axes. So what I'm going to do is I'm going to put a star, which means anything can be there, label. So it'll search for any function matching this called matplotlib.pyplot.something label something. Let's just run that. Remember, it is %sign p search, okay? Not %sign search. I don't know why it does the p, but it does. And that found nothing. Okay. I guess I did something wrong. Let's have a look. Maybe it's because I've imported matplotlib.pyplot as plt. Yep, there you go. Okay. So I can see there's an X label and Y label. You can pretty much guess how they work. Again, if you're unsure, you can go help, plt. I'm not sure if plt will work. plt.xlabel. Oh yeah, there you go. Wow, the documentation is really short. It must be a very simple function to use. Okay, it's got a single required parameter called xlabel, and xlabel is a string. Okay, a string is one of these objects that you put a quotation mark around and you type whatever garbage you want in there. And that is one value called a string. Okay, basically a string is text. Okay, let's give our plot some information. plt.scatter, that adds a scatter plot to the current figure that it's constructing. It then adds a normal line plot. It adds another normal line plot. Before or after these things, I can add labels. It doesn't really matter. Let's go x label. I can't even remember what it is. Time. Yeah, okay. Time in hours, as I recall. It's time in hours.
Yeah, and then plot x, y label.
Y label, I mean, you can guess it's going to be exactly the same, right? Why would it be any different? That would just be really dumb. Whoops. Okay. Distance. Okay. Well, meters.
Now, to be a bit pedantic here, we're only plotting distance, right? Okay, that's fine.
Oh,
yeah.
Okay.
So what if we have like multiple different things? Well, I guess we just put them in the legend and don't give y a label. Like if we have like distance and velocity and all the different things.
Doesn't matter.
I was just checking.
Battery life.
Yeah. So you want me to get a charger?
Okay.
It's back at BNG.
Okay. Have fun.
Okay, and you can see we've created this distance and time. Again, sorry, it's small to see, but
Worst
it is
case,
there.
you can switch.
Got an X label, time, hours, and a Y label. And title, similarly, let's go P search in here, PLT dot, again, I don't know exactly what it's called, probably has title in there, maybe label again,
What are you looking for?
data plot title.
Yeah.
There you go.
I think it's title.
Yeah, PLT dot title, okay. I'm going to guess, there you go, as I started typing it'll let me know anyway.
Yeah.
One required argument called label, it's probably a string again, whatever we want it to call. Let's call my plot title.
Cool. And last one's legend.
There you go, my plot title. Okay, last one. Again, these labels, they can come before or after the plt.scatter and plt.plot.
The only thing you have to come before is plt.show.
Yeah, that has to come right at the end. That's basically when you've finished constructing your plot and you want to show it. So if you actually want to show two separate plots in two separate windows, you do your plot, you do plt.show, and then you start creating another plot and you do plt.show. plt.show is like saying I've finalized all the things I wanted to add to my axes. I'm done. I want now to show this plot that I've constructed. Okay, so plt, let's see, let's again p-search legend. Whoops. Where is the mouse? There it is. Okay. Let's go plt, p-search, plt dot star legend star. Look at that, there's fig legend and there's legend. Well, I know legend's the right one, but I'm just going to choose legend. So we'll go help plt.legend, see what it says. Okay, again, documentation can be long, it can be quite daunting. I would just scroll to the top, check what the absolute essential arguments are. Okay, scroll, wow, see quite long. Yeah, okay, doesn't want to be nice. Doesn't clearly say which are the required arguments. Okay, oh here you go, call signatures, legend. And you can give it no arguments. Well, that's interesting. Let's find out what that does in a moment. We can also give it legend and then one input called labels. Well, it's only one input, but we can input multiple labels. So how do you think we might do that? plt.legend. Well, simple way would be using a Python list. That way you can have multiple labels in here. Label 1. Hello. Oops. Okay, because that's one object. And this is me guessing that that probably will be okay. And in fact, it will turn out to be okay, but often you can guess if you look at the signature. Let's actually see what happens if we call legend without any arguments, as it says here that we can do.
What's that going to do for us?
I don't quite know.
It's going to... No, nothing. No
Well,
handles
wait.
with labels found to put in the legend.
There
Yeah.
we go.
Oh, now the other thing, Murdoch, I think the question wants us to put the legend in the top center.
Yep, okay.
Yeah.
So I've run it now with the actual labels and you can see they've shown up.
Yeah, which is a question in the chat. How do we change the location of the legend?
Okay, yep. So let's go to help location of, sorry, what the legend. Okay.
Because that's one of the questions
Yep.
there.
So let's go help plt.legend. We're going to have to troll through this documentation.
Zoom.
And it's just a fact of life.
It's probably going to be right at the top, I'd suggest.
Yes, probably.
So if you just zoom up the top, and then we'll go
So
down.
Right now I'm looking through a list of other parameters.
Oh, it's the first one, lock.
Oh, there you go. There's a parameter called lock. Okay. Well, it's an optional parameter.
Yep.
It's called lock. That tells me all I need to know, how to use it.
So
It's
comma,
optional, so I have to go lock equals.
lock equals.
And then I have to give it a value. But what value should I give it? Well, it tells me
Well-
here in the documentation, these are the values I can give it.
And we want, for the question, we want top middle.
Top middle. I can either
this-
write top, let's see, upper
Center 9.
center is what it says. It's the correct way to do that, and we've got to write it exactly as it says. Or I can be annoying to anyone reading my code and write 10 or 9,
9,
sorry,
yeah.
if I wanted to just be
A pest.
annoying for no reason.
Yeah. Woo! Wet air.
Yeah.
Label 1, hello and bye.
Yep, there you go.
There you go.
Okay.
So, yeah. what is it? Help plt.legend. Yeah. Cool. Okay. Well, I think we've basically covered off that question. Question number 4. Shall we go on to question number 5?
Sure.
Okay. In systems dynamics, what are system archetypes? Dave, are we just getting rid of this systems archetypes crap for the final?
Well, I don't know. The problem is, unless you went to the guest lecture, which neither you nor I nor Murdoch did, you're not going to understand what this question means. What it's asking for. The
answer to this question is be a good little student and watch the echo recording of the guest lecture or flick through the lecture slides or something. I'm sure at least the 3 tutors in the room right now are probably going to argue to not have this on the final.
I'd be pretty upset if that question was on the final.
Yeah, so the final is getting finalised in the tutor meeting tomorrow, I believe. The day before, woohoo! So yeah, hopefully it won't be bad. Let's move on to the next question.
Yeah, okay. I think Ramesh said only the lecture from one of the guest lectures was accessible. I think it was the person who came and talked about statistics. Don't take my word for it, but I think that's what he said, right?
He only said the statistics one was, so the one by Dan on...
Okay, yeah, so if only the stats lecture is accessible, then there will not be questions on system archetypes. So, flush it.
Yeah.
Don't worry about it.
Don't take my word for it. Do look up the email or whatever, but that's what my understanding is, that only the stats lecture is going to be accessible. That's my understanding.
Okay, next question. Use scipy.integrate.ode int routine to solve the initial value problem for a set of first order differential equations.
Yep.
Okay. Excuse me.
So, thank you, John.
You're welcome.
Thank you for that segue.
Got a belch.
So, this question really is just a matter of knowing how to use ODE int. You have to do it yourself, once just to get used to it, how to use it. It's really not a difficult question if you know how to use the function, really. So I would suggest learning this function. I think there's probably a good chance it'll be in the exam. I don't know,
certainly will be an ODE in question in there.
Yeah.
And in this example, it's worth 10 marks, so it's well worth knowing how to do it.
Yeah. Okay. So let's begin by, I guess, looking at the question. Use the scipy.integrate.ode int routine to solve the initial value problem for a system of first order differential equations. So, first of all, you really have to understand what the question is asking, which let me go up on the board. And as I understand, a lot of you have not solved ODEs before, so you may not understand, you may not understand all the language of this question, so I'll try and break it down a bit. Okay, I'm on the screen. Okay. So, we've got these 3 different equations. We've got h1 prime, shorthand for derivative of h1 with respect to time. Okay. h1 prime is equal to 2h1 plus h2 plus 5h3 plus e to the negative 2t. h2 prime, again, meaning derivative dh2 on dt. Okay. Negative 3h1 minus 2h2 minus 8h3 plus 2e to the negative 2t minus cos of 3t. Okay. And then h3 prime, again, meaning dh3 on dt. How quickly it's changing with respect to time. 3h1 plus 3h2 plus 2h3 plus cos 3t. Okay. So they call this an initial value problem for a system of first order differential equations. What that means is we know, at initial value at some time, t, in this case t equals 0, usually what you have. At t equals 0, can you see? At t equals 0, we know the value of h1, h2 and h3, okay? We have h1 equals, what does it say, 1, h2 equals negative 1, and h3 equals 0, is that right? Yeah. Okay, oops, h3, okay? So we have that. And the idea is, if we know the initial value for h1, h2, and h3, and we know the time, that tells us the derivative of h1 and h2 and h3 with respect to time, which means we have all the information we know in principle to see how this system changes with time and to solve for what h1, h2, and h3 are doing given any time, what their values are as a function of t. In principle, we have the knowledge we need. To actually solve this is fairly difficult, like it's not straightforward, so for this kind of problem we would frequently use a numerical package just like this, okay, where we basically enter what the ODEs are, we enter the initial values, and it goes ahead and it solves it for us, giving h1 at all these different time values, h2 at all the different time values, and h3 as well. Okay, so now we sort of...
The charger?
Yep, okay. Whoop. So now we sort of understand what the problem is asking. Can we switch? How do I do that?
Yeah,
Click
just
that?
transition.
Okay.
Boom, you're back.
Okay. So now we sort of understand what the question's asking. Let's have a look. It tells us to use scipy.integrate.ode int. Okay, it's been kind to us. It hasn't just said solve it.
Yeah.
So first thing you should probably do is, if you don't already know how it works, let's look up the help.
Yeah.
And I may have to import the package first before it will let me.
Yes.
Yep. Okay, so let's import scipy.
Excuse me.
And do it again. Okay, it's still not happy. I have to import scipy.integrate. Okay. And then help. Okay.
Boom, we're in. Okay.
Okay, let's again scroll to the top. Usually that's the best way.
You may notice the example in the documentation is the exact same as the one lab where you had to do an ODE int.
Oh.
I wonder why.
Okay. Again, look, tons of arguments you can provide, tons of them. Most of the time, just concern yourself with the necessary arguments, the ones that are not optional. So, func, why not, and t. After that, it starts listing the argument name equals something, which means it's optional. Okay, so let's try and just use it with these bare minimum arguments first, because trying to comprehend the whole thing is just too complicated. So first of all, it needs a function. Okay, it needs why naught. Okay, probably the initial values, that would make sense. And then it needs t. We don't quite know what that means yet. So let's have a look. Parameters. Func. Okay, callable. Means it needs a function. This input actually needs to be the name of a function. And it needs to, this function needs to take inputs y and t. And it can take in more, but at the bare minimum, y and t. Okay. Computes the derivative of y at t. So what that means is we need to give ODE int a function where we can input the current y value, like h1, h2, and h3, and the current time, and it will give us back the derivative.
Yep.
Now, it only accepts one function of this kind, as you can see. So a question I had is, how do you put h1, h2, and h3 in here? Because it looks like it's only going to solve it for y, right? It can handle one variable y. Well, the answer is that you have one variable y, but you represent it as a vector. Actually, I can do it on the screen here. So we're going to have our y, okay, and conceptually, the y, we're going to keep in our minds that all the time the y is actually going to be a numpy array filled with the 3 different h values, okay? So it's going to have, h1, h2, h3. And you can take and this is a vector, you can think of it in your head as a vector. Oops, numpy.array, sorry. And the derivative of that vector is just, y prime. This is not valid syntax, I'm just trying to show you, let's say dy dt, numpy.array, array, and it would be d h1 dt d h2 dt d h3 dt. Okay. All right. So the first thing we're going to need to use this function, this ODE int, the first thing we're going to need is a function which takes in y, this vector, and it takes in the time t, and it outputs the derivative. Okay, let's just work on that for now, okay? Let's not look at the other things yet, just work on that. So we need a function. Okay, def, let's call it mydev for derivative, okay? It needs to take in, it says here, let's have another look, func callable yt. or callable ty. Then it says if the signature is callable ty, then the argument t first must be set to true. Well, that sounds complicated. Let's just go with the easier one, okay? Well, if you don't have to do anything special, just callable yt. So y is going to be the first argument over the left here, and then t. Okay. Okay. And remember, y is only one parameter. Okay, it's not like h1, h2, h3. There's only one object. Yes, the object can be decomposed, and you could look inside of it and find 3 different values. But it's just one object. It's just one array. Okay. Right. Well, to make things a bit simpler for myself, I'm just going to write at the beginning of the function decompose y. I'm going to go, okay, h1 equals the first thing in y. Remember, y is a numpy array, as down here, okay? So we're going to do that. We're going to do h2 equals y1, and then h3 equals y2. Okay. All right. Then, what is h1 dt? Okay. Because we need to output, this function needs to output this dy dt. That's the requirement. The function needs to take in y, and take in t, and then output dy dt. So we're trying to get these 3 values in our array. So let's define what they are here. So dh1 dt. Can you bring up the question again, please? Okay. Oh, it's on the board anyway. Okay. Yeah. dh1 dt, well, we've got that written as 2 times h1. Whoopsie daisy. 2 times h1. FYI, you can't write 2h1 like that. It will not understand that in Python or most programming languages. You do actually need to write 2 times like that. So 2 times h1, okay, plus h2, okay, plus 5 times h3, okay. Good thing about Python, it does respect BIMDAS. It will actually do the multiplications first before doing the additions. So it's not that's a nice aspect of Python. Plus e to the power of negative 2t. Well, I can tell you that np.exp will take e to the power of something. Okay, that one you should probably just remember. It comes up fairly often. Okay, that's looking right to me. That's looking like the first equation. Yep, yep, yep. Okay, dh1 or dh2 on dt is negative 3 times h1 minus 2 times h2 minus 8 times h3 plus 2 times np.exp negative 2 times t minus np.cos, again, something you should probably remember, np.cos, np.sin or sin, dh3 dt equals 3 times h1 plus 3 times h2 plus 2 times h3 plus np.cos 3 times t. Okie doke. Oops. Okie doke. And just to make it nice and neat so I can, clearly see what's going on, let's put in some spaces. Python is okay with that. It'll just make things a bit clearer. Yeah, let's not do that. There you go. So that's kind of nice now. When you align it like that with the spaces, you can easily compare it to the sheet and make sure it's right. So that looks good to me.
Nice.
Okay, so now we've constructed the 3 individual quantities. We need to reconstruct. This function, remember, needs to return dy on dt. So it needs to form these 3 into an array. Okay, so dy dt equals numpy.array dh1 dt, dh2 dt, and dh3 dt. There we go. Alrighty. And then, and then let's just return that, dy dt.
Yeah, cool.
Now this function, it does need to be defined before we try and run ODE_int and give it this function. So this does need to occur near the top somewhere before you actually run ODE_int. Otherwise ODE_int, we're going to be doing scipy.integrate.ODE_int, and we're going to be passing it the name of this function. If the code starts at the top and evaluates from the top, if it doesn't yet know what this function is, it's going to throw an error, okay? So if this function definition was below down here somewhere, it's going to get to this line before the function's ever been defined, and it's not going to be happy. So we've got to put that first. Bit annoying, because I like to have the function definitions at the bottom. Okay, we're going to need scipy in here, so let's import scipy.integrate. Could you bring the thing back?
Yep.
Import scipy.integrate, and that will be sufficient for us. That will import what we need.
Felix with the last second power.
Okay, thank you, Felix.
What percent are we on?
I don't know.
Not much.
Yeah, we're getting the backup juice right before the stream was about to cut out, I think.
Yeah.
Before the laptop went dead. Okay. So we've got this function. We've got our first argument sorted out for ODE int. Let's start looking at the other ones, okay? We also need to give it y naught. Oh, okay, well that's very simple. We'll just go mydev and then y naught. And then here we'll just set the initial values. Y naught equals numpy.array. It's initially equal to 1 for h1,
neg 1
negative
and 0.
1 and 0. Okay, well that one was easy. Now we need to give it t. T, well, I mean, that could mean multiple things. Maybe it's asking for how long we want to simulate it for.
I think in this case it's a range of time values.
Yep.
So, I don't know, do we give it like a linspace? Oh, yeah, a sequence of time points for which is solved for y.
Parameters, t, colon, array. Immediately tells you. NumPy, when it says array, assume it means NumPy array, okay? They're used so often, they just call it an array. A sequence of time points for which to solve for y.
Yeah.
Okay, well, the number that we want to solve for depends how fine we want our plot to be, I suppose.
Yeah.
Let's just solve for like 1,000 values. That sounds good to me.
Yeah. So yeah, plot the graph. Yes. So we're plotting a graph. So yeah, let's do like a linspace of however many.
So I think the question says solve where for t in 0 to pi on 2. So linspace
inclusive.
It's coming up here nicely for me. Start is 0. Stop is pi on 2. So np.pi divided by 2.
Yep.
And
100 points
equals, sure, we'll do 100.
And we want the endpoint as well. So
yes, this is something.
True.
Yeah. This is something else to point out. It's I guess technical and something you could easily miss. It does say for t in 0 to pi on 2, and it's got square brackets around that. So it's a closed interval, meaning it wants the t value for 0, and it does want the t value for pi on 2. It actually wants the endpoints. So we can go endpoint equals true inside this linspace, and what it will do is it'll include 100 t values. It'll make sure 0 is in there at the start, and also pi on 2 will be in there at the end.
Yep.
If we said endpoint equals false, it would go all the way up to pi on 2, but not including pi on 2.
Yeah. So if you just can you just start typing in np.linspace again on a new line?
Sure.
Yep. Just make like a little help dialog come up. So you see how it says endpoint.true there on the screen now. Oh, does that mean it's on by default?
Yep. It says endpoint equals true, which means if we leave that out, it'll assume we want it.
All right, cool.
Here I've put it in true because
just to be very pedantic.
The default.
And by default it's 50 in a linspace. Cool. Okay. Yeah.
Yeah.
Hey, I've learned something today.
Yeah.
Woohoo!
Ret step. Don't know what that is. Let's not worry about it. And D type. I do know what that is. Let's not worry about it anyway. Okay. So I think that's all we need.
In there?
Yeah, we've got to put t-vals. Okay, that seems like all we need to use the ODE and function, because I only needed those 3. So we needed, let's see, function, y naught t. All the rest are optional. We've got function, y naught t. The function needed to be callable. In other words, a function that takes in y and t, gives you the derivative. Yep, we've got y first, then t, gives us the derivative. Okay. You can see we put the name of our function in there. Okay, all looks good. What does it return? It says it returns y, an array of shape length t and length y naught. Now, what that means is it's going to return a 2-dimensional array, and each row, well, first of all, the first dimension is the number of rows. Okay?
So there's a row for every time step.
Yeah, there's a row for every time step, and then within each row, the length of each row is going to be the length of y naught.
Okay, so we'll have a column for each function then.
Yeah, so you're going to have a row for each t value, and then within that row, we're going to have the 3 values for the y.
So we can slice up that returned array to get our individual h1, h2, and h3, right?
Yeah. Let's go. I'm going to go.
I think you've defined y twice.
Yeah, this was just like an example down here.
Cool.
Let's go. I'll call it yt because it's kind of a function of t. We've got our t. Actually, I'm just going to call it t-vals is fine. T-vals yt. Okay.
Yeah, sure. Okay.
And what I might just do is run this, and we'll just have a look at what it outputs.
Okay. So that all ran happily, nice and fast.
Yep, it didn't have any issues. That's good. So let's go y naught. Okay, and those were the initial values. Okay, good. T-vals. Okay.
Cool, we got our t-values in there.
Yep, so it's trying to solve for the value of y, which is the vector of h1, h2, h3 of all these t-vals. And then look at the answer that we got from scipy.integrate
YT.
YT.
Oh, lovely.
Okay.
So notice like these are actually this is 3 columns of data. Earlier when we looked at the lin space, that was just Python making all the like that was just one row and Python making it all display on the screen. But now we actually have distinct rows and columns. Yeah, so each row has 3 entries in it because we have 3 columns.
And each of these corresponds to the time value given in the t-vals.
Yeah.
So if we, do we have So the third one, for example, here corresponds to the H1, H2, and H3 values for the
evaluated at 0.0317 whatever.
Evaluated at that time. Yep. Okay. And of course, if we want to extract a particular one, say I want the 15th, at the 15th time value. So let's check, t-vals 15.
Yeah.
Okay, yep, good enough. That's where I want to
extract
H values at that point.
At that point.
So we go YT, and all the Y values are stored in rows together, so we can just pick out the whole row.
Yeah, the 15th row, right?
Yep.
Cool, okay.
And we get a whole row. And then if we wanted particular YT 15, if we just wanted the H1 value, we'd pick the 0th column within that.
Okay.
Give us that straight up. Or the H2 value, that one, or the H3 value, like that.
And what if I just wanted like all the returns for H1, for example?
Yeah, so you'd use this slicing syntax again, where for the columns we specify just colon, which means pick everything. Every row. Sorry, not every column. Pick every row.
Every row.
Which means every time value.
And the second column.
Yep, 0 indexed, so it'd be the H3 value for all times. So that's the H3 values then.
Cool.
For all times.
Well, I think we know how to separate it all out to plot it now.
Yep. So let's go. Oops. How do we go? There we go. Let's go. H1t equals YT all rows, but we want 0th column. H2t equals YT all rows, but we want the first. H3t equals YT and then 2. And don't forget we have our t-vals as the independent variable here to plot along the x-axis.
Okay.
And these are the 3 dependent variables. Okay. So what does the question ask now?
So we want to plot H1 in red, H2 of green, and H3 in blue, appropriate title, X label, Y label, legends, etc. Okay.
So let's just start plotting H1t in red. I have to put the x values first, the dependent variable, which is t-vals, H1t, and then C equals, this is the color,
yep.
Make it red.
So to get a full list of those colors, just look in the help for plot.
Yeah.
Yep. Now, you can combine all this into one plot statement, but it's easy to just do it on separate lines.
Yeah, I don't even know off the top of my head how to do it in one.
You literally just comma separate it all, like t-vals, thing, color spec, t-vals, thing, color spec, like, yeah. But it's nicer and easier to read if it's all separate
this
lines.
is cleaner to read anyway, so this is what I would prefer.
H3T
C
and blue.
Yep. Okay, and then at the end we have to do plt.show to finalize and say, okay, those are the 3 plots we want on the one figure. So let's just have a look at that first.
Boom. Woo, that's cool.
Looks good to me.
Yep.
Okie dokie. And what else do we need to do?
We want title, X label, Y label, and legends.
Okay, I think we've already done that, but I guess I'll just do them quickly again because that won't take long. plt.xlabel.
Time.
Yep, time. Sure, seconds, I guess.
Yep.
Don't actually know what it's measured in, but plt.ylabel. Y, I guess.
Y, yeah.
And we're going to do plt.legend, and the 3 labels we want are going to be H1, comma H2, comma H3.
Cool. And we there?
And I believe these are in the same order that you put the plots on. So first of all, I put plot H1, plot H2, plot H3. So here I write the legend in the same order too.
And what are we missing? Title.
We are missing a title. So
yep. So yeah, let's add your title. These are like free marks really. I mean, we probably won't deduct too many if you forget them, but
Aha.
Yeah.
There you go.
Cool. Okay. Pointless plot. H1, H2, H3. Cool.
Yep.
We've got everything. Yeah. Wonderful. We've got it done. Cool. Gee, that question took a bit longer than I thought it would.
Yeah.
Okay. Last question of our sample exam. So just a bit of timekeeping. We're nearing 3 hours since we started. So counting in the fact we started a little bit late and our computer has crashed about 4 times, yeah, we're basically on track to finish in time, and that's been explaining everything to you guys. So hopefully if you've done all your study and you're not please do get a good night's sleep before your exam. Hopefully you guys will be able to power through it all and just smash it out. As I said at the start, do time budget your questions, so if you are taking too long on something, you can just leave it and come back later if you have spare time. And just try not to get too demoralized in your exam if you get stuck on something.
I think it's really possible with practice to become quite prepared, because there is a fairly limited scope of functions which you're going to be asked to use. Like ODE int probably going to come up. Make sure you know how to use that.
It will. I can virtually guarantee you will be asked a question of the same format. Here's some random differential equations. Shove it all into ODE int. Off you go. np.linspace. You're going to linspace is used all the time. Plotting, basically plotting, it's the same thing every time you want to plot something. You will probably have to plot something for all of the Python questions, so being familiar with plot is going to be very necessary.
That I would also write down or whatever, or know how to do regression using the polyfit and poly1D, and then also how to do interpolation, cubic or quadratic or whatever interpolation is asked. And that I feel like that will cover a lot of what could appear. Just writing those things down even. Let's do the last
question. Two different designs for a digital computer circuit are being studied to compare the amount of noise present. Okay, so you have two different designs and two sets of magical noise numbers. So we have 5 samples each. One of them is 19, 20, 19, 30 and 8, and the other one's 40, 55, 50, 35 and 70. And the two questions are, find the mean and standard deviation for circuit design 1. And the second question is about null hypotheses. So we'll get to that in a sec.
I'm just going to write in the data here.
We'll smash it in.
C2 equals numpy.array 40, 55, 50, 35 and 70. Okay, and oops, we'll import up here. And import np. And here's how you find the variance. You go np.var. Okay, it's pretty simple.
I think what standard deviation.
Does it?
Yes.
Okay, in
so
that case.
You will need to change this numpy.arrays to np.array.
Nah.
Oh yeah, you're right. It might have worked anyway. I don't know.
You don't also get the involved by
Okay. NP.
ABG, I think.
I think it's mean.
No. Okay, cool.
So we do that.
Okay, let's see. What does that give us? Oh, it gets us two numbers that seem
look at
vaguely.
that. Standard deviation and mean, just like that. Extremely easy with NumPy.
It's extremely easy if you know it's numpy.std and numpy.mean. So for statistical things like that, standard deviation, probably std, mean, average, probably .abg or .mean, variance, .var,
population standard deviation,
all silly shit like this. Lamau, hope you know a bit of statistics, otherwise you have a bad time. Okay, cool. Then, what is a possible null hypothesis in this case? What is the alternate null hypothesis?
I don't know, John. Why don't you tell us?
Well, I think one possible hypothesis is that circuit design 2 has more noise than circuit design 1.
Oh, what's the null hypothesis?
That it doesn't. Yeah? I can't remember what this shit is off the top of my head.
So noise, if you say noise of 1 equals noise of 2, you're saying that there is no change?
Yeah, there are two possible null hypotheses. One of them is that the noises are equal.
Yes.
And the other one is that circuit hypothesis is that 1 is actually less than or equal to.
Or you could technically say the change in noise is equal to 0, and then your null hypothesis is the change of noise is not equal to 0.
Right, okay, so the hypothesis is...
What's the actual question?
What is a possible null hypothesis in this case, and the alternate hypothesis?
So what are you trying to prove?
Well, in this case, I think what you're trying to prove is that either one circuit has better or doesn't have better noise characteristics than the other one. But, I mean, how you phrase that precisely is a null hypothesis.
So
that's an interesting
question.
question.
A null hypothesis here may be that circuit 2 was observed to have more noise, but just due to random fluctuations, and that can happen if you measure the same circuit many times. Eventually, statistically, you're going to find it has a lot of noise sometimes, just randomly, and sometimes it's going to appear to have no noise. Again, just due to pure randomness. The null hypothesis would be that there's no real significant difference between circuit design 1 and 2, and that the additional noise observed was
pure coincidence.
Pure coincidence. And if you actually wanted to, make that a bit more rigorous, you would find out what is the chance that this could have happened out of pure coincidence as opposed to out of a meaningful difference. But the null hypothesis is that, the difference observed, basically random noise, stroke of luck. That's basically a null hypothesis, in my understanding.
Question from the chat. Will any question involve importing data from a .csv, for example? Good question.
That seems possible, yeah.
I know a lot of people got, probably a little bit salty on lab test number 5 when there was import from CSV. And if you didn't remember the exact import from CSV thing, then you probably got...
That was easy enough to enter by hand, but yeah.
So np.gen from text.
Yep.
I'm hoping that if there is a question involving importing from CSV, we will just give you np.gen from text.
I'm also hoping it just has, space delimited, whatever the default is, so that you don't have to... It's good to know, but I feel like this is the kind of thing where you could get the answer for how to do this in 5 seconds from Google, so it's not really worth our time to assess you on can you remember np.gen from text. Once again, exams getting finalised tomorrow. Hopefully we can make sure no one writing the exam does anything silly. We've basically got through the sample exam in 3 hours. Woohoo, go us. How many viewers we have at this point?
Oh, look, we still have a fair few.
Dwindled down to 6.
We have 25.
Oh, okay, that's pretty good. Yeah.
Okay.
Yeah. I guess we should wait a bit for any more viewer questions.
Yeah, any more questions from the audience? Anyone not clear on anything? We are at your service for another couple minutes, should you desire. Let's chuck this on whiteboard for a second.
I noticed that you deleted all the code for it, but back in question 5 when we were talking about ODE.
ODE, yeah?
I was a bit confused on why you had after the num equals 100 brackets, you had something equals true.
Endpoint equals true.
Yeah.
Okay, so endpoint is an optional argument for linspace. If you set endpoint to false, let me whiteboard this. No, it's to do with open and closed sets.
Oh, right.
So by default, endpoint is true. So if you do linspace,
have you switched over, Felix?
Yeah.
from 0 to 50. By default, that will give you linearly spaced variables in the closed set of closed interval from 0 to 50. Now, if you were to set endpoint to false, you would get 0
I
to...
think you mean round brackets there.
Yeah. So this is end. True. False.
Is that correct? Do you want both double open interval, or is it just open at one end?
Oh, that's a very good question.
Let's find out.
We can find out.
Oh, we're still in Dvorak.
What was the question?
And the last question was the mid-sentence.
No, we're still going.
We're almost finished.
Yeah, we're nearly done.
We have questions.
Cool. Okay. That's live. We're live right now. Coming at you live from anywhere.
Oh, you're right. It is the single open interval. That's really weird.
Yeah. Okay, so
usually you'd want to use that to exclude 0.
Yeah, so this is how endpoint works, I guess. So I don't know if you can make it so it's a double, roundy boy, not including interval. If you want to exclude 0, for example, I guess you could do linspace from 50 to 0 and then reverse the array or something silly afterwards.
You would just do a slice and you take everything from index 1 onwards.
Yeah, so you do a slice.
But that doesn't do what you want.
It takes out the first thing.
It won't give you a linear space between 0 and thingo.
You just reverse
what you really want with the linspace, you want the half open interval the other way around.
You gonna take another photo?
Nah, it's all good.
Start with a question from the chat asking, can you differentiate a function that poly1D returns?
Yeah, I don't see why you couldn't. Like with the ODE int
Can
thing.
you differentiate it?
Yeah, I mean, of course, right? You can always differentiate a polynomial.
Here's an exercise. Why don't you take?
Yeah, I mean, why don't you give that a go yourself?
Take the array. The array, the length of the array will give you the order of the polynomial, or order of polynomial plus 1.
Yeah.
The first coefficient will be x to that, x cubed or whatever, then x squared, then x1.
Yeah,
You
yeah.
could write a function which takes that array and then outputs the
Yeah,
derivative.
yeah. So yes, you definitely can. Yeah, polynomials are differentiable by definition. So yeah, cool.
Not if you have
Anything else? No.
There's a question on here saying, can the last question of the mid-sem be discussed?
Of the mid-semester, which question was that?
That's the last one.
Let me fang it up real quick. Of like the actual mid-semester? It's all good. I should have it here. Where's internal? Oh shit, do I have it here? Oh fuck, okay. Git lob it is.
It's quite possible there's an inbuilt method to differentiate the poly 1D as well, but if there is, I don't know. I don't know what that is.
This is where you import sim.
I think I must have had a loose PCIe connection in X. I moved the Wi-Fi cards and now it hasn't crashed yet. Fuck me. Okay, mid-sem, exam question. Okay, so the last question of the mid-sem, Sophie?
Yes.
Question 4.
New exams.
I've got it up here, John, if you want to.
Yeah, okay. The checksum, the checksum question. Yeah, what about it? Everything?
Well, it's someone in the group actually asking.
Oh yeah. Yeah. Drill some more detail out of them, and then we can have a gander.
Eumerithio.
Okay, so
Odd parody.
yeah. Oh no, not on parody. It's like dopey parody. It's eight parody.
Oh, dumb parody.
Yeah. So greater than 9.
Yeah, John, CPU at 7% and other applications running, that's definitely hard refill.
Okay, so this is the last question of the mid-sem. So you are asked to write a function which takes a 16-bit input, so a half word, and checks using this checksum scheme here whether or not the data is correct. So the whole idea of checksums generally is that if you have say some kind of transmission method for data which isn't particularly reliable, maybe it's noisy. Good example of this, is like Wi-Fi or whatever. You want to make sure to see if there's been any errors in transmission, right? So you use, one or more bits to, say there's some rule that I can follow where, in this case, if more than 8 bits in here are 1, then this checksum bit needs to be 1. Otherwise, the checksum bit should be 0. So let's manually do this example we've got here, for example. We've got 1, 2, 3, 4, 5, 6, 7 bits in this part of the string set to 1, but our checksum bit is set to 1. So we've kind of broken our rule here, which means that we've got some kind of problem here and we need to return whatever error condition we're supposed to return, right? So this input has failed our test. The checksum bit should be 0, but it's actually 1, and we've got a problem. So if I check the question very quickly, it's bit 7. Yeah, so if the checksum is invalid, which in this case it is, then our function should return 0. If the checksum is valid, then we return 1. So let's write up an obvious one with a valid checksum. 0, 0. Okay, so this one's very obviously correct. No bits are set to 1, which means our checksum, well, we don't have more than 8 bits set to 1, so checksum should be 0. So in this case, we return a 1, because this is correct. This is incorrect. So, now, without going to a full bog implementation of how we might actually do this, in general, the way you would probably want to approach this question, given that you're counting bits, the easiest way to do that is with logical shifts. So you can, the two instructions you'd probably use the most to do this is
LSR.
Yeah, LSRS, setting flags. Now the reason why we want to set flags, let me pull up a chair real quick so I can not die. When we do a logical shift right, and set flags, so I'll just draw the very end of our 32-bit register so I don't go insane drawing boxes, So we have bit position 1 here, bit position 0 here. The S, the last thing that gets shifted off, actually goes into our carry flag here. So this is a handy little hacky way to shift off 1 bit and actually be able to use it, right? Because if we've got something in the carry flag, then we can do some cheeky stuff like, is it ADC, add with carry?
Yep.
Yeah, right. So add with carry, if we give it R0, R1, R2, what that's going to do is R0 equals R1 plus R2 plus the carry bit. Just that little bit there.
What about just using a add with a conditional code on it, like add CS R1?
That needs IT blocks.
Oh, okay, all right.
Yeah, so that's one way you could do it. So what you could actually just do here is add. Can you do fucking? So add with carry R1 of 0. That's going to be R1 plus 0 plus the carry bit, right? So, am I out of frame? So yeah, if you do logical shift right setting flags, the last bit, so the first time you do this, for example, the first LSRS will be the checksum bit. It'll put that checksum bit into the carry flag. Then you can do this, and okay, that should be on. Assuming R1 was initialized to 0 before you did this, R1 would now contain the value of the checksum bit, either 0 or 1. Yeah, so that's one way to do it. You could also just do a bit mask into a register. So the way we would do a bit mask for the first bit.
I think, yeah, maybe we should show them how to do it without using only instructions they've seen. So
yeah,
LSR,
so not spooky instructions.
Yeah, LSR, conditional branching,
yeah.
and adding.
Okay, so if we just wanted to get the first bit, we can do a bit mask. So if we remember the truth table for AND, which I'll draw up here. Okay, so truth table for AND. If we just want to extract 1 bit out of, however many bits of stuff, we can set one of the inputs to just one, B. And then if we kind of just look at the top half of this, then the output equals A, right? So for the bits we want, we set B to 1. The bits we don't want, we set B to 0, and the output's always just going to be 0. So to extract our first bit, we can do AND into R0 of R1 and the number 1. If it helps you to think about it conceptually, we can also write 0B1 for just like binary 1, which is the first digit in binary. So that we'll put into R0. So okay, assuming R1 contains this, that will put into R0 just the contents of the first bit. Yeah, and then we've essentially done all of this kind of without the extra steps.
Cool. So, what in terms of what's on the whiteboard, what's actual code and what's you explaining?
Okay, so let me draw. What's a comment? At?
Yeah.
Okay. Yeah. There with a little circle. There we go. Get a pink circle.
Is it right if I give a go now, John, to show like a complete solution? Or?
And then, I guess this would be LSRS like R1. Fuck. I'm not being consistent with what register I use here, excuse me. Let me like consistentize this up. Okay, add some consistency. Cool, so R0 contains the checksumming thing, and fucking R1 we're using for whatever. So notice after you've done this, you'd have to then shift it across if you do it with a bit mask.
Okay, so let's have a function called, can you see this on the thing?
Yes, you can.
Okay.
You got all of that.
Count bits. Okay, and at the top we're going to have input equals R0, and then output equals R1. Okay, so we're assuming we've already set R0 to the value we want to count the bits in, and then the output, the number of bits, is going to be put into R1. So what I'll do is I'll just start by going, I'll check the last bit and see whether or not the last bit of R0 is 1. So I'll go ANDS R0 and then just 1. Okay? Because that 1, of course, in binary, you know, is 0B 0 0 0 dot 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 0 0 1.
Do you need a question, sorry?
Okay. so when you AND R0 with 1, it's going to give you 1 if, like this, if the last bit of R0 is set, and otherwise it's just going to give you 0 if the last bit of R0 is not set. So it will set the 0 flag, the Z flag, if and only if last...
The screen can't read that. It's too small on 1080.
Oh, really?
Yeah.
Is that...
And it's blurry. And it's really
Oh, that's out of focus actually. I can put it
really
put it back into focus.
Yeah. Sorry. What's that?
the classic crystal clear tuner.
Yeah.
So
better?
Just wait for it to load.
Okay.
Yeah, no, I don't. This camera just will not focus this board. It'll
Oh,
focus
just
the other
bring it
one.
closer,
Yeah,
just-
there we go.
Okay. So yeah, if we AND R0 with 1 and we put in the S that actually sets the flags, the 0 flag will get set if and only
Is
if
the
the
camera
last bit of
1080?
R0 is 0.
Camera only records.
Okay. So
No,
then
it should go to
let's
1080.
see if
So we
let's
set the
branch,
FPS down
if
so we
the
can get
last
1080.
bit was equal to 0, let's
Show us the
branch
options.
into let's say next. So we'll continue on.
Yeah,
Right?
that's
And we'll worry about what's going to happen in the next later. Okay. Okay. But otherwise, if the 0 flag's not set, that means the last bit of R0 was 1.
In transition.
Okay. So we're actually going to add 1 to R1.
Is it?
Oh, right at the top
It's
here. We
fine,
should
yeah.
probably start
Also,
by.
the camera wasn't 1080.
No, it
before.
wasn't. Had to go 1080.
Let's get eraser.
Problem is the webcam always focuses on the closest thing.
Input is R0, output's
Designed to
R1.
capture your
Let's
face.
go.
Yeah. There you go. Now
Count
it's 1080.
bits.
It's not
Is that
much
visible
better.
up there?
Yeah.
Okay.
There we go.
Yeah, let's
The
actually.
camera wasn't in 1080 mode for some reason. We just like bumped it
Oh,
to 1080.
wow, okay.
So
Yeah.
Alright, so we're going to start by setting the count to 0, sorry. Then we're going to go
It's still fucking blurry. Yeah, so.
next, actually. That's going to be where the next goes. Okay. Okay. We're going to and it. We're going to set the 0 flag.
It gets this side
Right,
screen.
after we set the flag, we know whether or not the last bit of R0 was 1 or 0. And then to prepare to check the next bit, let's logically shift the R0 right by 1. So LSR 1. Okay. Yeah, if it was equal to 0, then right now, if the 0 flag was set, then the last bit was equal to 0. We don't want to increase the counter, so let's just go BEQ next. And just continue. And go on to the next one. Otherwise, we want to add onto R1, 1. Okay? Yep, looks good to me. The only thing is this is going to keep looping. It doesn't know how many times to logically shift R0. It doesn't know how many bits to check. So for that, you would also add a loop in here, like every time it goes through and next. Let's use R2 for that purpose. Mov R2 0. Every time it goes ahead and checks a bit, we're going to add onto R2 1. Okay.
Why? Sorry. Don't worry.
Okay, alright. Alright, okay. And then before we go checking the bits, we're going to see... Actually, no, after we check the bits, we're going to see compare... actually, no. Up here. So let me just put some extra things in here. Let's see. There, we're going to have add R2 1. If we've already checked 32 bits, so we do need to check it when R2 is equal to 1, with R2 equal to 2, 3, 4, 5. There are 32 bits in the register, so once it's about to check the 33rd bit, then we want to not do that. So compare R2 with 33, okay? And if that's true, we want to branch to, let's say, return label, let's say. Okay, that'll have that, that'll go the next. And then we'll have a return label, which pretty much just ends the function. We could put BXLR here if we wanted to, make it a proper, top LR. The top, we could go push LR. Okay, so it begins by setting R1 to 0, R2 to 0. R1 is going to be a counter, keeping track of how many bits are equal to 1. R2 is just keeping track of how many bits we've checked, because we only need to check 32. If we could just get stuck in an infinite loop, constantly counting. And then this is kind of the meat of it inside this next. First, we're going to add 1 to the number of bits that we've checked. We're going to check the first bit now, so R2 will be set to 1. If R2 is equal to 33, then we've already checked all the 32 bits, so we should just go BEQ return, and return will just bring us out of this function back to wherever. So that's that part. Okay, otherwise it ANDs R0 with 1. Right, remember 1 is this string of zeros in binary with a 1 at the end, and ANDing with R0 will get us either 1 or 0 as the answer, and give us 1 if R0 has 0. So 1 if R0 had a 1 at the end. And the 0 flag will be set if R0's last bit was equal to 0. Yep, so we're ANDing that, we're logically shifting R0 to prepare for the next loop in a moment. And yeah, if the 0 flag is set, then we don't need to increase the counter, so we just go BEQ next and we go back up. Otherwise, we add 1 to R1 and then the counter for how many bits have been set to 1, and then we go back up there. So I guess to illustrate, let's say, we don't have 32 bits, let's just say we have 8 bits or something, 1, 1, 0, 1, 0, 0, 1, 0. First of all, it checks that, it goes, okay, Z flag gets set, and then it will just go to next, and then it will shift this whole thing right. 1, 1, 0, 1, 0, 0, 1. Then the 0 flag will not be set, right? and then it will add 1 to R1 and we'll go back to next. And then it will shift the whole thing right again. It'll go 0B, 0, 0, 1, 1, 1, 1.
Just get a freaking PCIe one.
0, 0, 1, 1.
The PCIe ones are cheaper.
0, 0, 1, 1. Why am I getting confused? 0, 1, 0, 0. Then the 0 flag will get set, so it won't add a thing. And it just keeps shifting, and it keeps shifting all the way until it gets to the end. And once it's done 32 already, when it gets to the 33rd one, it aborts, and it just actually goes BQ return, and it just goes to the return bit, which makes it go back to wherever the function was called from. So that just uses instructions you should all know and you should have all used before, I believe. Key here, I guess, is you need to set the flags when you do the AND operation, and then you branch conditionally based on those flags.
Just a 1080p.
Yes, there are more
30p.
clever ways to do it, probably
really
using
good.
ADC and stuff, but if you're not confident using some of these
Just
extra
playing more
instructions,
channels
then
and having great.
that's how you would do it, just using the instructions you should know. They're all on the cheat sheet. Okie doke.
Cool. Any other questions?
Give 5 minutes for the group chat and the stream.
No one makes sheet for Firewire anymore. I don't think HDMI and Firewire is the combination you're going to make work. This thing has USB 3 ports, use those.
Good, we got a question.
Ooh. Observe, orient, decide, act.
That's not. What's that got to do with this course?
What the fuck's an observe, orient, decide, act?
That's
You
a.
fucking-
That's like comp 30. That's like business decision. What? That's I'm.
Fetch, decode, execute.
That's this. That's not a thing that's in this course. That's a business decision making.
Yeah, I'm trying to think what the fucking observe, orient.
No, they mean. I think they mean fetch, decode, execute.
Yeah.
Do they mean fetch, decode, execute?
Oh,
It's in the revision.
It's in. Okay, if it's in the systems dynamics lecture, don't worry about it.
Didn't Ramesh say that's not accessible? Huh?
Yeah, I thought Ramesh said system. Wait, what?
Wait. Ramesh gave us two. I was told by Ramesh that
I don't
it's
know.
not accessible.
There's an email. Isn't there an email we sent?
Like observe, orient, decide, act. I mean, I guess it's like fucking what it says on the tin. Like you look
Yeah.
around, you orientate yourself, you decide, and you fucking yote.
Yeah, it's a business decision making doctrine. It originally came out of the U.S. Army.
I mean, okay. Look, here's
It means think before you act.
okay. So here's a really simple example, I think, of observe, orient, decide, act. Okay.
the Wikipedia page.
If I like draw like a you know, if I draw a cookie on the whiteboard. Okay, so the first step.
The Thursday lecture said something.
All right. Step 1, I observe the cookie. Step 2, I orient myself towards the cookie. Step 3, I decide to eat the cookie. And step 4, I fucking eat it. There we go. Right, we're done. Yeah. Oh, Felix will demonstrate by holding up a cookie for me. Okay, so I observe the cookie. I orientate myself towards the cookie.
You're not in frame.
Right, okay, the cookie. Now I decide I'm going to eat the cookie, and then...
The orient part is orienting the cookie to fit in your mouth first.
No, it's orient yourself. That's very
Oh, you
important.
orient yourself around the cookie.
I have to make sure I'm in the right direction for maximising the cookie eating.
Okay. Yeah, you can.
That's a good cookie. Yeah, okay.
I don't have any idea.
Someone likes an explanation.
What's that?
We're trying to get
Q&A.
clarification on what's actually assessed
Q&A, David.
because
Yeah, there was something in the systems dynamics lecture that no one actually knows how to teach, and it's not sure whether it's
Observe, orient, decide, act. We just gave a great example of me eating a cookie. So someone did ask about stack stuff.
okay.
Um,
Right, so it does
Can
say
you
in the
talk a bit
lecture
about
slides
push
that
and
it is
pop?
accessible, but I was verbally told by Ramesh it wasn't, so I don't know what.
I'm sure you
I'm gonna go off
But
this
you
and
didn't
just
Ramesh
apologize
write
to
the
like
lecture
15
slides.
people I've said it.
So this question, can you talk about the push and pop? Are you asking how the stack works or what the specifically push and pop? Because push and pop are just equivalent to changing the stack pointer and storing something in memory. So I'm not sure if you're asking about very specifically the words push and pop or whether you're asking about the stack in general.
Maybe someone should email Ramesh.
cool, yeah.
It's just he's not clear when he talks to you, but he's clear.
Sure. Okay, yeah. So push and pop.
Yeah. It wasn't too bad. It's just
Okay, so
like when I Because
I
you
guess
said it wasn't.
if we want to talk about push and pop, the first thing we need to consider, you know, we're operating on the stack, and I think the best way to think about the stack is by thinking about it as what it is, which is a first in, last out buffer. So when I say a buffer, I guess we mean like a place that we can put stuff. And then first in, last out is exactly what it says on the tin, right? So, you know, just for explanation's sake, I'm going to draw a stack that grows upwards. On our disco board, you know, we're always throwing this around, it fucking grows down. Yeah, look, that's a pain in the ass to draw though, so let's...
Whenever growth sort of grows down, just for practical reasons, theory is exactly the same.
Yeah, like, it doesn't actually matter. Does the number get bigger or smaller? Like, okay, sure. So, you know, if like, let's say we're like stacking up some bricks, right? And if I put brick number 1 on my little stack of bricks, so I've to use the terminology, I've pushed brick number 1. Now I'm gonna, you know, push brick number 2, and, you know, push brick number 3. Okay. So you can see the order I put these in because I've given them little numbers, right? Brick number 1 went in first, 2 went in second, 3 went in third, right? So when we pop stuff off the stack, the way we do it is we take it right off the top. So if I take off brick number 3, so brick number 3 was the third brick to go on the stack, right? It was the last one to go on. But because it's on the top, it's going to be the first one to come off, right? So brick number 3 comes off first, and then brick number 2, and then brick number 1. So in that way, it's, you know, first in, last out. So the way that this then translates when we're writing assembly, we write a function. Okay. Coolio. So let's say I've got, you know, yes, my func returns with a vengeance. And my func is going to call some other functions inside my func. So what I'm going to do is I'm going to write some pushes and pops, and I'm also going to sort of draw up my stack frame while I'm at it. So when I say stack frame, I mean like the contents of the stack that's relevant to this function. So the first thing we're going to do, because we have nested function calls in my func, which we haven't got to yet, we're going to push that link reg. Cool, squiggly brackets. So if I draw my stickity stack, sure, I'll just use the edge of the board there. That's actually a straight line. Cool. LR. Right down the bottom, we have our link register. Right, coolio. And let's say I want to use some registers, which according to the function calling convention, my function is responsible for saving. So R4 through R12. Let's say I need a few extra registers for this function, you know, whatever. Push, squiggle, 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 register 4 to like register 7. Okay, sure. So we will have R4, R5, R6, and R7. Oh, not RZ. Now, every time I do this, my stack pointer as well is getting incremented. So at the moment, this is the SP. So you might just grab an orange.
Got a green or a brown?
I like that. Okay, sure. So I'll draw my stack pointer as a little orange arrow. Okay. So here's my stack pointer, right? So the stack pointer is just pointing to like the next sort of empty slot. Yeah, okay, cool.
I think it's actually pointing to the end of the top of R7, I think, actually.
Yes. It points to the top thing on the stack.
Okay. Excuse me, sorry, it does point. Points to the top thing on the stack. Okay, sure, and then, you know, let's put in fucking some dots to represent that we're actually doing some work in here. Sure, you know, we'll BL to, you know, let's say we branch to BSP, you know, audio, whatever. You know, fucking 420, play a tune, you know, have fun. And you know, maybe BSP, you know, let's just write in like BSP stuff in case it uses stuff, right? And you know, don't forget, our stack pointer will also move along. Cool, so if our, you know, program execution is up to the point where we're now inside our BSP audio function, you know, whatever, this is what our stack looks like. So our program counter is, you know, somewhere inside BSP, right? Now, let's say our BSP audio whatever function is finished. and we've returned to BSP audio function. So I'm going to also draw the program counter in orange. So the program counter is now after this. We've returned from here. So what does our stack look like now? Well, our BSP audio function will have cleaned up after itself. So the stack will no longer have BSP stuff on it. Well, more specifically, the data will still be there, but we don't care it's there because the stack pointer is now pointing at R7. Okay, so we'll now zoom ahead to the end of my func, where we'll go pop. Now it's very important to remember, first in, last out, that we pop in roughly the correct order that we pushed. So we'll go pop. We need to pop these guys first, because they went in after the link register, which means they'll come out before the link register. Link register was in first, link register comes out last. So we'll pop R4 to R7. Now for each one of these, it's going to take what's here, and I mean, it doesn't technically erase anything, but it's just easier to explain by me erasing on the board.
Oh, just move the stack pointer.
And then decrement the stack pointer down. And it'll do that. So, these values technically aren't getting erased. It's just moving, it's just, doing stuff and then moving the stack pointer. Cool. So that's this step here, is we just move the stack pointer down and, we don't really care about these values. Sure, they do get left there, but that doesn't really matter. You can think of it as being as good as erased. Cool. Then our last instruction, of course, pop link register. So yeah, our link register gets read out, put in our link register. Stack pointer is now at the bottom of the stack.
You're missing a step. Missing a step.
I'm missing a step?
Very cool.
Oh, and of course, our function's over. BXL.
So can you write how you would do push without using push and how you do pop without using pop?
Push without using push and pop without using pop?
Yep.
Sure. So
that was in the lectures too.
Screenshot
so.
now.
Yeah. Because push and pop are just convenience commands. You can do the same thing yourself.
So we'll pretend there's nothing in my little stack slots here. And we're pointing to the end of the stack. So
Are you talking about the manual
push
blocks, or
without
are you
push.
talking about LDMO ASTMDB?
now I believe.
Just one at a time.
Oh, so let's
Oh, yeah.
let's do this in the very ARM specific way where our stack actually grows down. So this does make sense.
It's not ARM specific, it's like literally every CPU architecture.
So our stack point is going to point to the top of our stack, which is the end of our stack. Am I still in frame over here?
Yes.
Yeah, cool. Okay, right. So what do we need to do? So currently our stack pointer isn't actually pointing at like a little slot in our stack. So we need to decrement the stack pointer, right? So we can do this. Let's do this a simple way first, not using any spooky commands. Sub SP4. Or we can do add SP -4, right? These two things, I'm sure you all know how to add friggin' numbers together. Whatever, let's use sub. So sub SP -4. Okay, stack pointer now points to our first little empty slot. And then just, let's say I want to store R0 at the stack pointer. Cool. This now contains R0. That's all very well and good. Now we can do this all in one line. But we can also just do str R0 SP -4. So these two things are functionally equivalent. They both do the same thing. That's one instruction, that's two. Now say we want to push multiple registers, we can also do that.
STMDB.
Yeah.
Leave all that there.
Okay, so if you want to, let's say we now want to do register 1, 2, and 3 as well. So DB. Does this automatically increment by 4?
Yeah, it automatically knows how much to. You're missing something.
Register list.
STMDB, SP exclamation mark, comma, and then the curly braces.
What does a DB do?
Decrement before.
Ah.
Okay, so what the hell does this do? You can sort of infer just by going through the different letters. So ST is store, M is multiple, and then DB is decrement before. So for each register in our register list, it's going to do this. It's going to...
John, are you going to do this anymore?
No. It's going to subtract 4 from the stack pointer, and then store that register at the stack pointer. Notice this exclamation point here. It will, do a subtraction from the stack pointer first, right? Because the stack pointer usually points at the first thing on the stack. So we always need to subtract to get an empty slot first. So this will then mean our stack pointer is going to be 1, 2, 3, 4 down here. 1, 2, 3, 4. There we go. So yeah, store multiple decrement 4. So if you look in the architecture reference manual, it actually tells you that push is an alias for this instruction. It's the exact same machine code.
No, I think that's correct. I think
And
push
then
is in
to load, it's the other way around. So L, D, M, I, A, SP, and then register list. Now, note there is no exclamation mark here. We do not want to increment the stack pointer before we do a load, because the stack pointer is always pointing at the first thing on the stack. So load multiple, increment afterwards.
I am convinced you do want an exclamation mark there.
You do?
Yeah, because the decrement before and increment after is already built into the instructions. That's what's DB and IA.
What is the exclamation point for?
It's just required by the instruction.
Okay, fuck. Apparently we need this exclamation mark. Or now, I don't know. LDMI. So that's equivalent to a pop. Stack pointer, exclamation, register list. And yeah, so that will load R4, increment, stack pointer, load, increment, and eventually our stack pointer will be up here. So yeah, as I mentioned before, these values don't actually get erased, but because, as far as the stack pointer is concerned, they aren't really referenced to by anything, you can consider them erased. The only situation in which you would actually have to care about the values left in there is if, say, someone's trying to hack your ANU.
Yeah. Say if you're writing cryptography code.
Yeah. So if you're writing code that needs to be secure, for example, we call this stack sanitization.
Yeah, and you're
you want to
keeping
delete everything on the stack, which means you would want to write zeros into all these registers.
But here's a fun fact which I was reading a paper on last week at the thingo. Did you know that C compilers are very smart, and if you just write zeros over something, it detects that you never read those zeros again and eliminates it as dead store elimination?
Oh yeah.
So you have to make really sure you trick the compiler into thinking you do something with the zeros.
Yeah. So we don't really cover doing cryptographically secure code, so don't worry about it. These numbers, although they're still technically there, if you look in the memory viewer, they're still there. They're as good as gone, because the stack pointer isn't pointing at them, right? The stack pointer says the top of the stack is R0, and I don't care about anything down here. So yeah, I hope that was a good explanation of the stack. Any other questions in chat?
And it says the solution of lab test 4 will be uploaded. I feel like it was briefly mentioned.
Lab test 4 is pretty similar to one of the sample exam questions. Yeah, and there's 4 different questions for lab test 4. I mean, I can bust out a solution if you're really desperate for one. Oh, excuse me. Cool. Nice. Anything else?
Nope, that's it from the chat.
Woo. Any questions down there? No?
You have a question, but you don't want it to be recorded.
He mentioned in Tuesday's lecture
Yeah.
that Monte Carlo is an example of something he would give us, but he says he used the word simple Monte Carlo.
Yep.
For example, coin toss.
Yep.
We practiced it because it's actually really simple. But
Yep.
what other kinds of examples can we look at? What, dice or I don't know.
Yeah, dice is something you can do in Monte Carlo. I mean, Monte Carlo essentially just boils down to doing, something randomly and repeatedly, and then looking at what you get afterwards and, making some judgment of that.
Right, you can solve the 1100 or something with that Monte Carlo search.
Yeah, sure. Probably not particularly relevant for engineers. Yeah. Yeah, the Brownian motion one. Well, yeah, the actual Monte Carlo part of it wasn't particularly complex. It was just some nasty, horrible math Well, actually, no, it wasn't even that bad, honestly.
We don't have any answers to
Yeah. But yeah, like so flipping a coin, dice roll, yeah, that's like all Monte Carlo stuff. Like the lemniscate problem. So the lemniscate problem in Lab 8 was a bit of a nasty one. Well, it's nasty in that if you don't know how to do Monte Carlo, all you see is, wow, this is a big angry mathematical equation. But the equation's actually already there for you. You just have to know, like, oh, I just have to check, does this equation return greater than 1 or whatever it was, So it ends up being pretty simple once you understand what Monte Carlo actually is, just the lab doesn't do a very good job of explaining it.
So you consider the lab one?
I would consider the lemniscate equation pretty simple. Once you have an understanding of how to do Monte Carlo, yeah, honestly it is pretty simple. Like, a good one to practice, for example, is draw a circle inside a box. So a circle of radius 1 in a 2x2 box, such that, the circle touches the edge of the box, in 4 points exactly. And then do a Monte Carlo simulation, how many points land inside the circle versus outside the circle. And if you do that, you will get an approximation of pi. That's a fun one. And then that one's also pretty trivial to optimize because, the circle is symmetric, right? So you can just do 1/4 of the box and it'll take you, a quarter of the time to get the same accuracy of results, I believe.
No, it's same accuracy results.
No, it is the same accuracy of results. Never mind, I'm blowing up my ass again. But yeah. You can do stuff like that. That's probably not a bad revision question to do actually. Just Monte Carlo of approximating pi. I hope I haven't just eliminated a possible exam question.
Someone asked sample exam question 2. Why do you need to push and pop R4?
So that was just me being a good little egg and following the ARM function calling convention. You don't need to do that. It's good practice. But yeah.
I guess the answer in terms of the calling convention is because he used R4.
Yeah.
And so R4 could have contained information from the code that called you.
So in the calling convention, the registers 4 through 12, if a function uses those, they are supposed to save the previous values of those registers and restore it before they return. Whereas R0 through R3, the function is allowed to use at will, and the caller, so whatever called the function has to save them instead. This is the ARM function calling convention. It's in one of the lecture slides on functions back from week 4 or 5, 6, 7, first half of the semester.
I think that might do it.
That might actually do it. Cool. So exams on the 6th. Do make sure you have a good night's sleep beforehand, at least 8 hours. It is scientifically proven to boost your performance, so if you're worried about failing, sleeping is the best thing to do. Just I don't know, go for a run or something, and then I don't know, I'm not going to endorse pharmaceuticals on stream. But,
Yikes.
What?
Right, yes.
Okay.
Cool. Anything else? Okay. Might call it there. If you have any other further pressing questions, my email inbox is always open.
Did we answer the question about solutions available?
Yeah. There's an answer.
You can always email probably me. I'm probably the most reliable responder out of all of them. Or David or Murdoch.
That's a joke, right?
I'm pretty busy on the emails.
Okay.
Anyway, or Wattle or whatever.
Okay.
Cool. Done.
Yeah.
See you later.
4 hours. Oh.
Just like to.
That is the most intensive study I've ever done. Oh wow, that was recorded as well. You're not gonna do the flushing the 56 chicken